Hello everyone, good evening. Am I audible to you? Shakti, co-host. Shakti, co-host. Message to host and panelist மட்டும்தான் இருக்கு, everyone இல்லையே. Right. Okay. Enabled. People attending online, I hope I am audible to you, and people who are watching it on YouTube, I hope I'm also audible to you. I'm audible to you also. All right. So we'll start with the session. Short introduction. I'm Sucharithan, Faculty for Science and Technology in Shankar IAS Academy. So welcome to the free session provided by Shankar IAS Academy, wherein the main aim of this session is to cover at least 200 questions and cover 100 themes in various subjects, wherein today we are going to discuss about science and technology. Before we start the session, I'll give you a general outlay of the session. I've taken 30 questions. So these 30 questions, they're taken from different field of science and technology, like space science, astrophysics, biotech, nuclear science, electronics, communication, information technology, nanotechnology, and then from basics of NCERT. Basically, at least 2 or 3 questions will be there in all these fields. Now, how we are going to approach this session is, first I will show you the question, and then generally, assume you're going to write your prelims examination. It's 120 minutes, where you have to attend somewhere around 100 questions. So I have assumed, or I have assigned somewhere around 50 seconds for each of the questions. So once I show you the question, so bar will run at top of the screen, wherein before it runs out, which will be in 50 seconds, please make sure you drop your answers. So all the answers that will be given as input through the Zoom meeting, I will take it as the answers, and then based on that, we'll proceed with the discussion. This is the idea, clear? So we'll start with the first question. Yeah, please wait a minute. Okay. We're starting with the first question in space science. I will display the question. Online people, I'm watching your messages on the Zoom. You can drop your messages here. The question on your screen now. So please zoom to the board. Okay. Do you want the board to be zoomed in? Is it not clear to you? Shakti, ஒரு level zoom வேணுமா? So that board மட்டும் தெரியுற மாதிரி. நான் தெரியாட்டி பரவாயில்ல, board maximum zoom வைங்க. Is it fine now? People who are attending on the Zoom? Yeah. I hope the Zoom level is optimum now. Okay. So based on the answers you have given, first one, ISRO can launch satellites up to 8,000 kilogram to the low Earth orbit. It is correct. So first of all, you have to understand what is the low Earth orbit. Let's say if this is the surface of Earth, and if a satellite is placed up to 2,000 kilometer from the surface of Earth, then you call it as a low Earth orbit. So it can be anywhere starting from generally 180 kilometer or up to 2,000 kilometer. You call it as a low Earth orbit, wherein of all the launch vehicles that India has right now, the GSLV Mark III, which is the heaviest launch vehicle of India, this is capable of carrying up to 8,000 kilogram to the low Earth orbit. So if you take the payload capacity of GSLV Mark III, to the low Earth orbit, that is less than 2,000 kilometer, it can carry up to 8,000 kilogram of payload. This can be anything, a satellite, a spacecraft, or even astronauts. Anyone or anything that can be up to 8,000 kilogram can be carried by GSLV Mark III to the low Earth orbit, that is up to 2,000 kilometer. Then when we talk about GTO, that is geostationary transfer orbit, where the satellites will be placed in a temporary orbit, and then it will be lifted to a very high Earth orbit, somewhere up to 35,000 kilometer. So for such orbits, this GSLV Mark III can carry up to 4,000 kilogram. Or in very simple terms, if you want to launch a communication satellite, which is much heavier, which has to be placed in a very high Earth orbit, India can send up to 4,000 kilogram. Wherein if you want to place any other imaging satellite or any other minor satellites which are placed at the low altitude, India can send up to 8,000 kilograms. So these are the launch capacities of GSLV Mark III. Based on this, first statement is correct. Second statement, India is self-sufficient in the production of liquid and cryogenic engines. This statement is also correct because the liquid engines developed by India, these are called as Vikas engines. First, they were integrated in PSLV, the Polar Satellite Launch Vehicle. So India is self-sufficient in liquid engine. You would have seen movies like the rocketry Nambi effect and everything that discusses about Vikas engines. Now coming to the cryogenic engines, right now India has two cryogenic engines. First one is CE 7.5. This is the first indigenous cryogenic engine developed by India. Wherein the largest cryogenic engine developed by India, it's called a CE 2.5. Wherein CE 7.5 right now it is operating in GSLV Mark II, wherein CE 2.5 this is operating in GSLV Mark III, which means two types of cryogenic engines are used by India. For both of them, India has self-sufficient capabilities. Or in other words, we can domestically produce it without any other country's support. Even though these cryogenic engines are inspired by the Russian model, right now India has indigenous capabilities. So the second statement is correct. Third one, GSLV Mark III has the highest success rate among all the launch vehicles of India. This statement is wrong. That's because when we talk about success rate, it's about how many missions you have sent and out of which how many missions were successful. If you take the success rate, GSLV Mark III has lesser success rate, wherein PSLV, that is a Polar Satellite Launch Vehicle, this is considered to be the most reliable launch vehicle of India. That's because in the entire service history, in all the commercial missions, so far only two failures. One was in 1993, the other was in 2017, which means this is considered to be the most versatile workhorse, or this is considered to be the most reliable launch vehicle of India, wherein the third statement is wrong. Based on this, answer should be 1 and 2 only. And after I tell you the answer, again, I will give you like 15 to 30 seconds reserved for any doubts. Online people, if you have any doubts, you can drop your messages quickly. Many of you have answered B, few of you have answered C, wherein C is wrong. Wrong answer. I hope you understood. How many failures for Mark III? Not required, sir. But when we were trying to send Mangalyaan, repeatedly GSLV Mark III was showing failures. And that is why the India's Martian mission or the Mangalyaan was sent through PSLV. So from what I've heard, it has very lesser success rate and also more number of failures compared to PSLV. This is sufficient. The numerical data is not required. Which has the highest success rate? Javelin, PSLV has the highest success rate. PSLV. Polar Satellite Launch Vehicle. PSLV has the highest success rate. We have one more question. Where CE is used? The cryogenic engine 225. By the way, Naren, CE20, CE25, both are same. CE25 is name of the program, CE20 is name of the engine. So CE2025 symbolizes the same thing and they are part of GSLV Mark III. What is the height of GTO? Kasturi ma'am, it depends on the altitude where you have to place the satellite. If you want to place a satellite at 35,000 kilometers, then the GTO can be up to 7,000 kilometers, and from where we will be raising it. Suppose if you want to place a navigation satellite somewhere around 10,000 kilometers, then 4,000 kilometers can be GTO. So this GTO depends on mass of the satellite and also depends on destination of the satellite. It has a variable range, but definitely higher than low Earth orbit. Is it clear? Can we go to the next question? All right. Coming to the second question related to the navigation systems. Okay, B is the majority of answer, wherein few of you have answered C. Many of you have answered A. Okay, we'll see this question. First one, navigation system in mobile phones can predict our location by trilateration technique. This is true. That's because when if I'm going to turn on GPS here, Now my phone is going to receive signals at least from 13 satellites. I repeat, since GPS has somewhere around 24 satellites, including the backup satellites, 8 to 13 satellites will send signals to my mobile phone. Now the mobile phone has a GPS receiver, which is going to calculate distance of the satellite from the mobile phone. I repeat, the distance of the satellites from my mobile phone is calculated. Based on this, your location will be predicted. So this method is called as trilateration. In very simple words, if you're going to electronically calculate sides of a triangle or sides of a shape, then it is called as a trilateration technique. And this should not be confused with triangulation technique, because triangulation technique, you use the angles of a triangle to determine its length. That is different. Where in navigation systems, they use trilateration techniques. Triangulation is used for land survey methods, wherein this is used in navigation satellites. So the first statement is correct. Trilateration technique is used by the navigation systems to predict your location. Second one, Navic system by India has satellites in geostationary Earth orbit as well as geosynchronous orbit. This is also correct. That's because you classify satellites generally placed at a very high altitude into two. First one, you have geostationary and then geosynchronous. So both these satellites have one common characteristic, that is time period of the satellite. I repeat, time period of the satellite, or in other words, time taken by the satellite to complete one orbit. That is the time period of the satellite. So time period of the satellite equals to rotational period of Earth, which equals to 23 hours, 56 minutes, and 4 seconds. Or other words, approximately you can write 24 hours. Now the Earth is going to take 24 hours to complete one rotation. The satellite is also going to take 24 hours to complete one rotation. That is called as a geosynchronous orbit, something like this. The Earth is taking 24 hours, and also the satellite is taking 24 hours. Now, in this, you have two subclassification. First one is geosynchronous, which means this condition is met, but this is not generally placed on the equator. In other words, it is a little bit tilted away from the equator. So it covers certain parts of the northern hemisphere, and then it covers certain part of the southern hemisphere. Or in very simple terms, if you take the equator to be like this, it makes a H-shaped path, or the area covered by geosynchronous orbit. I repeat, geosynchronous orbit, GSO. It will be like a H-shaped path, wherein sections of area will be covered. That's because the Earth is rotating in a different angle and the satellite is orbiting in a different angle. This is called as geosynchronous. Wherein geostationary Earth orbit, GEO, it is basically a special case of GSO. I repeat, geostationary Earth orbit, it's a special case of geosynchronous orbit. The only difference is it fulfills this condition, but it is placed above the equator. I repeat, this is placed right above the equator. That's called as a geostationary Earth orbit satellite. So what is the statement given here? It says NAVIC system, or in other words, IRNSS, Indian Regional Navigation Satellite System. It has satellites in geostationary Earth orbit as well as geosynchronous orbit. This is true. That's because India has placed 4 satellites in geosynchronous orbit and 3 satellites in geostationary Earth orbit. So this has been asked in previous year, the older UPSC prelims also. That's because you have something like this, 7 satellites, wherein 4 satellites are in geosynchronous orbit, which makes a H-shaped coverage. And then 3 satellites are in geostationary Earth orbit. So that's why if you see here, GEO, 3 GEO, and then 4 GSO. So the second statement is true. Coming to the third statement, NAVIC SPS signal, which means standard positioning signal, are interoperable with other global navigation satellite systems. So here, global navigation satellite system means it has a global coverage. Throughout the world, you can use it, starting from Arctic till Antarctic. Everywhere you go, if a navigation signal is going to give you a coverage, if it's going to provide you signal, you call it as a GNSS, Global Navigation Satellite System. We have 4 global navigation satellite systems. One is GPS, owned by USA. And then you have GLONASS, owned by Russia. And then you have Galileo, that is owned by European Union. And then you have Beidou, that is owned by China. So these are global navigation satellite systems. Wherein if you take NAVIC or IRNSS, these are regional navigation satellite systems, RNSS. Now, here it says NAVIC signals are interoperable with other global navigation satellite systems, where in recent times when they updated the ISRO's webpage, we understood this is true. For GS students who are attending the session, So I particularly told you that the navigation systems are not interoperable, which means if I have a GPS receiver, that may not operate with GLONASS. That is true. But here, Navic and GPS, these two are interoperable because there are certain bands in C band, L band that are interoperable, which means if I have a GPS receiver, it can receive signals from GPS, which belongs to USA, and also it can receive signals from IRNSS, which belongs to India. Certain bands are interoperable. So this statement is also correct. This is an update with respect to the data given in GS classes. So make sure you update your notes. 1, 2, 3. All the three statements are correct. So answer is D. All the statements are correct. Second question, answer is B. Do you have any doubts in this? Can we go to the next question? Okay, Naren has a question. Why this H shape is formed? For that, you have to understand the Earth is rotating from west to east, wherein the satellite is rotating like this, where the equator is here. So what will happen when it is here? This is going to cover this section of the land. When it is there, it is going to cover other section of the land, but the Earth would have rotated. So wherein you can search in Google for GSO, because it's very difficult to explain it here since I don't have animation. Just search for geosynchronous orbit and then go to the image search, put a GIF file, you will understand. Wherein right now you have to imagine it in a 3-dimension. Clear? It makes a H-shaped coverage. Sir, one more doubt from Karthik, wherein he's asking for location trilateration. For land survey, you said no. What is it? Okay. So Karthik, I said if civil engineering graduates are present online, they'll understand. It's called as triangulation. The method used in land survey, that's called as triangulation technique, wherein angles of a triangle is used to measure the sides. That is triangulation. But navigation uses trilateration. Okay, and one more one. So how many regional navigation system India has? So Nitish, India has only one regional navigation system. Generally worldwide, we call 2 regional navigation systems which are operational right now. One is called as the IRNSS or NAVIC, which is owned by India. The other one is QZSS, quasi-Zenith satellite system, that is owned by Japan. These two are the regional navigation systems that are completely operational now. So does the one like interoperable makes it GNSS, since it looks very vague? No. See here, what we have given here is the signals are interoperable with other global navigation satellite systems. Where we have not specified it's interoperable with all global navigation systems or something like that. We have given it is interoperable with other global navigation systems, which could be anything. Clear? Okay. Kindly display trilateration. You don't have to take a screenshot or copy it here, wherein I'll be sending it to your YouTube link. So wherein in the description, once the class is over, we'll be updating the PDF. You can download it from there. Okay. Coming to the third question. Okay. Now here, I've mentioned 4 important satellite systems of India, and I've mentioned the spectrum which is being observed by these satellites. First one, Cartosat, it uses visible light. True. This is often called as India's eye in the sky. That's because it creates very clear images. The spectral resolution of Cartosat, it is speculated to be up to 25 centimeter, extremely high zooming capabilities. It is the sharpest civilian remote sensing satellites. I'm using the term sharpest. That's because it's considered to be sharpest in the world, the entire world, because there was a satellite called, in fact, it is still operating. There is a satellite called World View, 3, which is owned by USA, by a company called Maxar, USA-based company called Maxar. This had a resolution of 30 centimeter, but right now the Indian satellite, that is Cartosat, it has an imaging resolution of up to 25 centimeter, which means if you take the civilian satellites that are available for imaging capabilities, this has the sharpest image. So the first one is properly matched. Second one, hyperspectral imaging satellite. HISE stands for hyperspectral imaging satellites, wherein HISE it covers two regions. One is the infrared, the other one is the visible. If you are unable to comprehend all these radio spectrums, understand electromagnetic spectrum, wherein it has 7 different waves. It starts from radio. It covers radio, micro, infrared, visible, UV, X-ray, and gamma. And here, the general classification, which I tell in the GS classes usually, you draw a line here, wherein these 4 are generally used for communication purposes. That is, radio is used for communication, microwave, infrared, and visible. You have had many questions related to VLC, visible light communication, and other, even infrared communication. So these 4 can be used for communication. Generally, we won't use UV, X-ray, and gamma for communication. That's because high energy ultraviolet rays, X-rays, and gamma rays, these are ionizing in nature, which means they can knock out electrons from your from the atoms in your body, which can lead to cancers, or on a longer run, it can even lead to genetic damages. So generally, when we talk about communication, we use these 4 for communication purposes. Similarly, for imaging purpose also, we can use all of these electromagnetic waves, especially these 4 electromagnetic waves. Because when you imagine taking a photo, you always imagine a lens that captures light. That is our normal phone camera. In fact, right now our phone cameras are capable of capturing visible as well as infrared. Right now, most of the advanced phone cameras, it uses these 2 parts of the spectrum, wherein for imaging purpose, we can use all 4 of them, especially in satellite systems. So here it is given HISIS uses infrared plus visible light. That is, hyperspectral imaging satellite uses infrared plus visible light. That's true. Second one is also properly matched because this can record thermal radiations, which means if there is a forest fire, or if some organisms are present under the canopy layer of the forest, all these can be faced using HISIS. Coming to the next one, RISAT. RISAT stands for Radar Imaging Satellite. Very important. That's because this is India's all-weather satellite system. This is India's all-weather satellite system. So all-weather satellite system means day, night, cloudy weather, rainy weather, irrespective of the weather condition, this can make clear images. So how this particular satellite is capable of making clear images means it uses microwave, basically. It is not going to collect microwave, but instead the satellite is going to beam a microwave that is going to be reflected from the land, and using that it creates a simulated image. In fact, the type of satellites are called as, or the type of radar used here, it's called as synthetic aperture radar, SAR. You can link it with the recent project NISAR, NASA ISRO Synthetic Aperture Radar. Basically, the NISAR also is going to perform the same function. It's going to take complete picture of the Earth periodically. So similar to that, here, RISAT, Radar Imaging Satellite, it's going to take clear pictures by sending microwaves and receiving them back from the land. Based on this statement is also correct. RISAT uses microwaves. Even though it's called as radar imaging satellite, which generally symbolizes radio waves, here it uses microwave. Third one is correct. Fourth one is resource sat, which is used for resource monitoring purpose. This also uses infrared and visible light. So basically, all the 4 are correctly matched. Answer is D. All the pairs are correctly matched. Answer is D. All the pairs are correctly matched. Do you have any doubts in this? So where can we get this info? Okay, so generally I took it from the ISRO's webpage itself. So if you go to ISRO's webpage, it has an option called Satellites of India, wherein they have divided into communication satellites, the Earth observation satellites, and then student satellites, small satellites, special scientific missions. So wherein I've covered most of them in this particular session also. So wherein these infos are taken from ISRO's webpage. Can you go to the next one? Sir, what's mean by NISAR? Karthik has a question, sir. So Karthik, NISAR means NASA ISRO Synthetic Aperture Radar. I repeat, NISAR means NASA ISRO synthetic aperture radar. So NASA is building a payload, a particular bandwidth, and ISRO is building one more synthetic aperture radar. So both these space agencies together, they're going to put a satellite that will have two different synthetic aperture radars, which uses two different bands. So using that, they are going to capture complete image of the Earth periodically. So it is estimated to be around 14 days. For every 14 days, we are going to take a fresh radar image of the Earth. The project is yet to be launched. Yeah. These satellites are only to the particular spectrum. Yes, these satellites are only for a particular spectrum, wherein generally a single satellite cannot observe the entire electromagnetic spectrum. Maximum thing is we have the AstroSat by India. We'll discuss about it, wherein that uses X-ray, UV, and visible. But most of the times, satellite can generally we build a satellite in such a way that it observes one or two part of the spectrum. Okay. Coming to the fourth question. Most of you have answered D, few of you have answered C. All right. First one, Gaganyaan will be India's first manned flight program. This is correct. So far, we have never sent astronauts to space. Mr. Rakesh Sharma, who was Indian Air Force pilot, he traveled to the space station called as Salyut 7. So this space station was owned and operated by the former Soviet Republic, which means Rakesh Sharma is the only Indian who has traveled to space. But he did not travel through any of the launch vehicles of India, wherein he traveled through the Russian launch vehicle because he traveled to the Russian space station. So when we launch Gaganyaan, that will be the first manned flight program, no doubt. Second one, the orbital module of Gaganyaan uses cryogenic engine for propulsion of service module as well as crew module. This statement is wrong. That's because for launching the Gaganyaan, that is the entire launch vehicle GSLV Mark 3 is going to be used. So right now, ISRO has an additional label. It's called as a human-rated launch vehicle. So which means it's capable or it is fit enough to send humans to space, which is just a modified version of GSLV Mark 3. Now, GSLV Mark 3 uses cryogenic engine, no doubt. So the cryogenic engine in GSLV Mark 3 will be used for launching the orbital module, wherein once the orbital module is launched, it has two modules inside. One is called as the service module, that is the SM. The other one is called as the crew module, that is the CM. We have mentioned it here. That is the crew module and service module. So here what you have to understand is crew module means this is the container where the astronauts will be present inside, which means it's a pressurized container with thermal protection systems. Wherein service module means it contains additional engines and everything so that we can just elevate the module to different orbits because we are planning to send them up to 300 to 400 kilometers. The altitudes are not yet confirmed. So the service module will contain liquid thrusters. I repeat, liquid engines, not cryogenic engines, that will be used for elevating them. So in short, Gaganyaan is going to be launched with help of cryogenic engine, but the orbital module will not contain cryogenic engine. The orbital module operates only based on liquid engines, not cryogenic engines. So the second statement is wrong. Coming to the third statement, Vyomanaut safety is ensured by parachute deceleration systems, which is developed by ISRO and DRDO. This is true. Recently, they have tested it. That's because when the astronauts are dropped or when they are going to re-enter into atmosphere, they face a lot of friction. So the crew module is safely encapsulated, wherein it has to be decelerated because when it enters inside, it will have somewhere around 250 meter per second. In other words, in 4 seconds, it will drop down at least 1 kilometer. But you have to reduce it up to 11 meter per second. This is the target set by ISRO. It has to be reduced up to 11 meter per second before it splashes into the ocean. So how are you going to decelerate? We are going to deploy parachutes. For additional safety, we have additional parachutes also. If the main parachute is deployed, and then if it fails, there will be additional parachutes so that the astronauts will safely splash into the ocean so that we can collect the module and they will be returned safely. Third one is right. First one is right. Second one is wrong. Answer should be C. Can we go to the next one? Do you have any doubts in this? Okay, coming to the next question, fifth one, related to deep space missions. Okay. The first statement, it says no spacecraft has landed on Uranus and Neptune. This is true. That's because the outermost planets, that is Uranus and Neptune, so far only one spacecraft has visited it, which means it has not landed, it has not orbited, but it's a flyby spacecraft. It's called as the Voyager 2, which was launched by NASA in the year 1977. It is active till now because it uses radioisotopes for acceleration, wherein right now it's present outside the solar system. Now, Voyager 2 is the only spacecraft that has visited all the 4 Jovian planets, that is Jupiter, Saturn, Uranus, and Neptune. So only spacecraft to visit all the 4 Jovian planets, Voyager 2, and also only spacecraft that had ever visited Uranus and Neptune, it is Voyager 2. So no spacecraft has landed. True, no spacecraft has landed in these 2 gaseous planets. First one is true. Second one, NASA was the first space agency to deploy a rotor-based spacecraft. In very simple terms, a drone. A rotor-based spacecraft on another planet. This is true. That's because in 2020, they sent a mission called Mars 2020. The name of the mission is Mars 2020, wherein it had a rover called Perseverance. So inside this Perseverance, we had a rotor-based, there is NASA sent a rotor-based spacecraft called Ingenuity, wherein this is the first spacecraft that made a powered flight on another planet. Now, the second statement is true. The name of the mission is Mars 2020 by NASA. And the name of the rover, the largest and heaviest rover ever sent to Mars, that is Perseverance. And then it had a rotor-based spacecraft that was called as Ingenuity. 2021. It reached there in 2021. Now, the third one, no space agency has landed on a comet due to high velocity and eccentricity of the object. This is wrong. That's because Rosetta Stone, a mission by European Space Agency, it has landed on a comet. So only one successful landing, wherein there is one more mission called Vega, but that crash landed. Only soft landing on comet, it was made by the Rosetta Stone mission by European Space Agency. Mostly we send missions to asteroids. That's because they may be rich in metals or carbon or any other hydrocarbons, wherein European Space Agency, it landed once on a comet. Sir, when we talk about the planets, should we include moon and not the planet? Ronak sir, no. When you talk about planets, we are talking only about the planets. But when you talk about planetary system, you can include moons. Or when you talk about solar system, you can include the moons. So 1 is correct, 2 is correct, third one is wrong. Answer is 1 and 2 only. Fifth one, answer is A. Do you have any doubts in this? Can we go to the next one? And by the way, if you're wondering what exactly is meant by eccentricity, the eccentricity means how much the focus is offset from an ellipse. Let's say if this is ellipse, and then the focus is present at the center, then this is like mildly eccentric. But if you take a comet, this has an orbit like this. It reaches very closer to the sun. So we call it as highly eccentric. So since it reaches very close to the sun, what happens? The temperature increases. And when the temperature increases, basically the hydrocarbons or ice, anything present in the comet, it burns. And that gives the characteristic tail, the gas tail formed by the comet. So comets have highly eccentric orbit, wherein if you take an asteroid, it has an elliptical orbit. If you take an asteroid, it may have orbit something like this. It will not approach very close to the Earth. All right. So generally, asteroids are present in the asteroid belt, or sometimes they may form Trojan asteroids, which we will discuss later, wherein comets are formed in a place called Oort cloud, which is present in the outer belt of the solar system. So outside the Kuiper belt, you have a place called Oort cloud. This is where the comet forms. So the path of the comet will be somewhat like this. It reaches very close to the sun, and then again it reaches the Oort cloud. The third one is wrong. That's because one landing so far. Answer is 1 and 2. Coming to the next question. All right. Unanimously, most of you have answered A. Very good. The answer is A, Mangalyaan. So the reason we took this question is Mangalyaan, when was it launched? It was launched in the year 2013, reached in the year 2014. It reached Mars in the year 2014, wherein they estimated the Mangalyaan will survive for 6 months. It's considered to be a technology demonstration mission, which means it is set to demonstrate a technology. That's all. We expected it to operate for only 6 months, but it operated till 2022. Only during eclipse, we lost connectivity with the Mangalyaan mission. The last year, they declared it to be completed. So these are the accolades that Mangalyaan holds. First one, a very rare phenomenon where China referred it as pride of Asia. That's because India was the first Asian country to successfully send a mission to Mars. Keep this in mind. India was the first Asian country to successfully send a mission to Mars. Second one is true. It got a US-based National Space Society Award. That's because till date, it's also one of the most economic mission sent to Mars because it used a method called as Hohmann transfer orbit. Repeat, it used a method called as Hohmann transfer orbit, which means the first phase is geocentric phase. That is, the Mangalyaan mission started orbiting around the Earth. The first phase, it was based on Earth. The second phase, after it gained enough acceleration, it was sent towards the Mars, wherein this trajectory was based on Sun. So the second phase was called as heliocentric phase. First, it orbited around the Earth. Second one, it made a trajectory based on Sun, and finally it reaches Mars, wherein it was captured by gravity of the Mars. The third phase is called as heliocentric phase. Mangalyaan went through very less number of tests. So the overall budget of the mission, it was capped to somewhere around 450 crore rupee, which is very less compared to the other Martian missions. Since it was a very innovative method and also a very cost-effective method to send it to Mars, it was given such awards. And also India was the first country to attain success in its maiden attempt. Be very careful when you read this statement because 2016 UPSC question, it says India is the only country that has attained success in its maiden attempt. That is the very first attempt, wherein that was true till 2020. India was the only Asian country, or throughout the world, India was the only country that has attained success in the Martian mission in its maiden attempt, wherein 2021, this record was broken by, or right now we can say the record is shared by a mission called as Al-Amal mission. Al-Amal mission, or sometimes called as Hope Mars mission. The importance of this mission is, this mission was built by United Arab Emirates, wherein this was launched by Japanese Aerospace Exploration Agency. So the record that was exclusively held by India, right now it's shared between India and United Arab Emirates. When you revise your old UPSC questions, make sure that you understand, right now India is not the only country that has succeeded in maiden attempt. All the three statements are related to Mangalyaan mission. Answer is 1. Can you go to the next option? I mean, the next question. Do you have any doubts in this? Okay. Next question is related to Sun. Okay, most of you have answered A. First one, sunspots versus coronal holes. Two different phenomena that we have to discuss. First, we'll talk about coronal holes. The concept of coronal holes. First thing you have to keep in mind is the picture that you see here. You see certain missing portions or like darker portions in the sun. This is called as a coronal hole. But if you use a solar telescope, and then if you're going to look at the sun, this won't look like this. Or in other words, coronal holes will not be visible because coronal holes are visible only in ultraviolet spectrum or sometimes in X-ray spectrum. It is not visible in normal light or visible spectrum. This is the first thing you have to keep in mind. But when we talk about sunspots, so sunspots, these are regions where the plasma is or the plasma flow is very less. These sunspots, they form in photosphere of the sun, the light layer of the sun. And this can be seen in visible spectrum. This is the first difference you have to learn. Second thing is generally coronal holes. So these are the places where solar storms will emerge from. So first you can write coronal holes are generally associated with solar storms. They're associated with solar storms. Second thing is these are formed generally when sun is having lesser activity or minimum solar activity. Lesser solar activity. All these are related to coronal holes. Wherein when we talk about sunspots, it can be seen in visible spectrum. It is seen in the photosphere layer. And very important, more sunspots are formed when sun is in solar maxima state. And these sunspots, they are mainly associated with particle events. I repeat, particle events such as coronal mass ejections, where stream of hot or ionized particles will be emitted. Ionized or magnetized particles will be emitted from sun. The last year we had a question related to the particle event from the sun. They've given like 7 statements and they've asked what are the effects that could happen if solar storm is reaching here. Understand, solar storm means it is generally created because of the coronal holes or wherever the coronal holes are present, wherein coronal mass ejections are created when sun is in maximum solar activity, where more sunspots will be formed. And one more thing to understand here is sunspots, they are not permanent. Generally, they are formed near the poles, wherein sunspots can exist for a few days or sometimes for weeks or even for months, wherein they are like a short time event. More and more sunspots will be created. There are times where sun will create more than 50 or 60 sunspots and then it disappears. So this recurringly happens, wherein coronal holes will sustain for a longer time compared to the sunspots. These are the differences. Based on that, first statement, sunspots are dark and cooler areas on the visible surface of the sun caused by magnetic activity. True. First statement is correct. Coronal holes are cooler and less denser regions in the sun's outer atmosphere where solar wind can flow. This is also correct. I told you to associate coronal holes with solar winds and sunspots with coronal mass ejection. So first and second are correct. Third one, coronal holes do not emit radiation. No, coronal holes emit ultraviolet and X-ray, wherein sunspots emit X-rays. No, sunspots are regions. These are like swapped. Sunspots are regions where you will not have radiation, wherein coronal holes are regions where you will have X-ray and ultraviolet radiation. Third one is wrong. First and second are correct. Answer should be A. Answer for this question is A. Do you have any doubts in this, online people? Okay. This may be a bit tricky to understand, but make sure you do a retrospective research, search in current affairs, search in the Hindu newspaper, Indian Express, and also go through the NASA websites. You'll understand. So updated classrooms, when it will be circulated. Okay. The updated material, you will find it in the YouTube channel itself, wherein if you're a GS student, we will send you through the Telegram channels, like how we have been circulating all the academic materials through the Telegram channel. If you're a GS student, you will receive it in the Telegram channel by today. Is it clear? Okay. Please explain third point again, sir. Here, I told you coronal holes are regions where solar storms will be emitted, and so the coronal holes will emit UV and X-ray radiation. Wherein if you take a sunspots, so these are regions with a very strong magnetic pressure where plasma will not flow. Or in other words, very reduced plasma flow or absence of radiation can be called as a sunspot. So which means here the statement should have been coronal holes emit X-ray and ultraviolet radiation, while sunspots do not emit radiation. That should be the ideal statement, but here the statements are swapped. So the third one is wrong. Clear? Any other doubts? Will the recording be uploaded? Yes, it will be available in YouTube, and also we will send it through the Telegram channel. Kartika Murugan, you have a question related to sunspot. See here, sunspots are regions where the magnetic pressure is more, and because of that, the temperature also will be lesser. Let's say this is the photosphere and chromosphere region. Let's say this is having somewhere around 6,000 Kelvin, for example. If you take the sunspots, these will have temperature of around 4,700 Kelvin, or in other words, somewhere around 4,200 degrees Celsius. At least 1,000 degrees Celsius lesser compared to other regions of the sun. That's because there is a strong magnetic pressure here. Imagine something is flowing out from here, and then I put a pressure here. What will happen? Plasma flow will be obstructed, and because of that, the temperature will be lesser, and also the plasma concentration will be lesser. That's called as a sunspot. Is it clear? Causes for coronal holes. That's one mystery that the scientists are studying right now. We have somewhere around 20 plus heliophysics observatories that are performing research. It's a very lengthy topic, wherein we have something called a solar dynamo mechanism or magneto-hydrodynamic dynamo mechanism. There are different mechanisms: alpha effect, beta effect, butterfly effect. There are different effects that explains this. That's a very lengthy topic. Let's not go into that right now. Right. Coming to the next one. Okay. I think in previous years, UPSC was giving questions related to the ELISA mission, or sometimes they give you a random term or a description of a mission, and then they ask you what that mission is related to, generally related to some international missions. Here, the keywords that you have to pick here: the spacecraft will get boost from Earth's gravity to complete 12-year journey, which means it's a very lengthy journey. Second key term here is asteroids. The third one key term here is Trojans. These are the three terms. So of all the missions, all these missions here, they are related to asteroids, no doubt. If you take Hayabusa, the answer is D, by the way. But anyway, I'll tell you what are the other options related to. If you take Hayabusa 2, it is a mission that was sent by Japanese Aerospace Exploration Agency. And this was sent to a single asteroid. It was sent to an asteroid called as Ryugu to collect samples and return. When it has returned during the COVID, somewhere in 2021, it returned samples. When right now it's on an extended mission, where it is traveling to a different asteroid right now. So this traveled to one asteroid, collected samples. Right now it's traveling to other asteroids. So it is not traveling to 7 Trojans, no doubt. Eliminate the first one. OSIRIS-REx. This was a mission that was launched by NASA, wherein this was sent to an asteroid called as Bennu, a carbon-rich asteroid called as Bennu. It has collected samples, and it started its return journey in 2021. Which means mostly by this year, mid of this year, samples from Bennu will be returned and it will be collected by NASA through the OSIRIS-REx mission, but it is not related to the Trojan asteroids because it has traveled to only one asteroid. Eliminate this one. DART mission, often seen in the news. This is again not related to Trojans. This was sent to a near-Earth asteroid. So DART mission was sent by NASA again, wherein this was sent to an asteroid called as Didymos. We sent it to a binary asteroid, wherein we crashed the spacecraft, or in other words, we made an impact using the spacecraft on the asteroid. That is, in future, if any spacecraft is going to, or if any asteroid is going to approach the Earth, we try to divert it. That mission is called as DART. So you can easily eliminate these three options if you have been following the newspaper, where the answer is Lucy. The importance of Lucy mission, first one, it's the first ever mission that is sent to Trojan asteroids. First of all, we have to understand what are Trojan asteroids. So Trojan asteroids means they share orbit with the planet. Trojan asteroids, they share orbit with the planet. Asteroids that shares orbit with the planet, we call them as Trojan asteroids. When in this case, if you take Jupiter, there are 2 points, that is Lagrangian point 4 and Lagrangian point 5, L4 and L5. In these 2 places, the asteroids will accumulate and they will not collide with the planet. That's because the planet is orbiting, the Lagrange points are also shifting, which means they will share orbit with the planet, but they won't generally collide with the planet. Most of the planets have Trojans, including Earth. So far we have found that Earth contains 2 Trojans. Now, we want to study about the Trojans of Jupiter. For that, NASA sent a mission called as Lucy. Now, Lucy is going to visit both Lagrange point 4 and Lagrange point 5, L4 and L5, through a complex maneuver. It will take at least 12 years to complete it. Even though when they launched it, they said it is 7 asteroids or 7 Trojans, but right now it is increased because certain asteroids are binary asteroids. 2 asteroids are binary. So they're saying it is going to visit 9 Trojans. So the numbers are not important, but remember, it's going to visit multiple Trojans in L4 and L5. Answer is D. Can we go to the next one? Okay. Coming to the 9th question. All right, we'll check the answers online. Okay. To understand this, first, there are these many elementary particles, wherein we are going to simply classify them into 2 types. First, you can write I think online most of them have answered A. Okay. So first, broadly, we are going to divide them into fermions and bosons. First, you can write it's broadly divided into fermions and bosons. So inside fermions, again, we are going to subdivide it into particles based on quarks and leptons. Particles based on quarks and leptons, wherein these elementary bosons, they can be further subdivided into gauge bosons and scalar bosons. Noted. Okay. Now, if you see this picture here, first of all, we'll talk about quarks. So quarks are like building blocks of present elementary particles. That is, if you take protons and neutrons, for example, I repeat, protons, neutrons, all these are made up of quarks. That's because at least 3 quarks combine together to form particles like protons and neutrons. In other words, hadrons. Hadrons means heavier particles. Repeat, hadrons, such as protons and neutrons, they are made up of quarks. There are 6 different types of quarks. We have up, down, charm, strange, top, bottom. We don't have to dwell into the details right now. Wherein if you take leptons, lighter particles fall under leptons. If you take electron, for example, they are not made up of quarks, but they fall under fermions. So electrons, or the opposite to it, what we call as positron, E+1, 0, or anti-electron, all these fall under leptons. Now coming to these, that is the gauge bosons. Then if you see here, all these are gauge bosons, gluons, photons, Z bosons, and W bosons. These fall under gauge bosons. Wherein what is the use of this? Do you remember when we discussed about 4 fundamental forces? First is gravitational force. Other one is strong nuclear force. And then you have weak nuclear force. And then electromagnetism, wherein gluons are related to strong nuclear force. In other words, strong nuclear forces mediated by exchange of gluons. Wherein these two, that is Z bosons and W bosons, these two are related to weak nuclear force or weak interaction, which means this is responsible for nuclear decay and also for nuclear fission and fusion. Wherein photons, they are responsible for electromagnetism. All electrostatic force, electromagnetic force, they are mediated by photons. Wherein out of 4 fundamental forces, I've given you only 3. There is strong nuclear force, weak nuclear force, and electromagnetism. What is missing here? Gravitational force is missing here because there is a theoretical particle called as graviton. It is not a detected, it's only hypothetical. So which also falls under gauge bosons. Now coming to the Higgs boson, very important since Nobel Prize was given for discovery of this one. Higgs boson, you can write, they are providing mass to the particles. Repeat, they provide mass to the particles, which means there is a invisible field in the universe called as Higgs field. Any particle that is interacting more, it is going to gain mass, or any particle that is interacting less, it's going to gain lesser mass. This is the basic. So quarks will make protons, neutrons, and heavier particles, wherein leptons makes lighter particles such as electrons and then anti-electrons, such things. Wherein gluons are related to strong nuclear force, photons are related to electromagnetism, bosons are related to weak interaction, and then Higgs bosons are related to mass. Based on this, if you read this one now, protons and neutrons are bosons. See here, protons and neutrons are bosons. No, wrong. Wherein photons are fermions. It is basically swapped. That's because protons and neutrons are fermions, wherein photons fall under bosons, which means the first statement is wrong. It is swapped. Protons and neutrons are fermions, while photons are bosons. Second one, Higgs bosons is responsible for giving mass to the particle. This is true. Higgs particle and Higgs field is responsible for providing mass. Third one, the universe has equal amounts of matter and antimatter. This is wrong. That's because initially when the universe formed, every particle had an opposite particle. If there is a proton, there used to be an antiproton with opposite charge. For electron, there was an anti-electron, or otherwise called as positron. Even for neutron, there was an anti-neutron. Every particle had equal or opposite particle that differs only by one number, wherein at some point of time in the universe, slowly matter took over, wherein the entire antimatter is destroyed. So right now we don't have antimatter, at least for a stable amount of time. So antimatter is only created in the labs right now. Labs like CERN, they have antimatter, and very small amount, in few milligrams, wherein generally in universe, 99.99% is filled only with matter. Where an antimatter, even if it is formed in the universe, it's not reasonably stable for longer amount of time. So this one is wrong. And by the way, the reason why antimatter disappeared and why matter formed, it's a very lengthy topic, wherein it's called as baryogenesis. Or otherwise, this is called as the charge parity violation. The event is called as CP violation. There was a violation that happened in the universe that slowly led to the complete destruction of antimatter, and matter took over the universe. So third is wrong. First is wrong, only second is correct. Answer is B only. Compared to all the previous questions, this is a bit tougher, I understand. But because we have finished space science, followed by astrophysics, and then we have to step into other topics. So generally, the end of each topic will be a bit tougher question. Coming to the 10th question about stars. Okay, many answers for question is this particular question is D. Most of you have given D answer. First one, Sun is a main sequence star. This is true, and it's composed of 91% hydrogen and 8.9% helium by number, not by mass. First one is wrong, because if you take Sun, see here, we'll talk about hydrogen and helium. There are two things that you have to consider. First is based on number. The second one is based on mass. So if you take in terms of number, hydrogen will be 91%, and then helium will be 8.9%, no doubt. The figures are correct, but it's based on number. That is, if you're going to take particles, if you're going to count them, 91% of the particle will be hydrogen and the 8.9% of the particle will be helium. That is correct. But if you take it in terms of mass, hydrogen is H11. It has only one proton and one electron. But helium contains two protons, two neutrons, and two electrons, much heavier. So in terms of number, they may be lesser, but in terms of mass, they are higher. So this contributes to somewhere around 70.6%, when this contributes to somewhere around 27.4%. Both of them together will contribute around 98%, wherein other elements will form rest of the part. In this case, first one is wrong. Till the last word you have to read. When it's not based on number, they have given it's based on mass. So the first one is wrong. Second one, Sun can neither undergo supernova explosion nor form a black hole. This is true. That's because only massive stars, they can undergo supernova explosion, and then it can result in black hole. To understand this, first you have to see this picture, wherein left-hand side of the picture taken from NASA, this is related to an average star, wherein right-hand side of the picture, that is related to massive stars. Left-hand side, average star, right-hand side, massive star. Now, if you take an average star, the top portion of the chart, initially the star starts from a region called as nebula, basically the collection of gases and dust particles, and then it will form a structure called protostar, a form before the star, followed by that every star, that is average star or even a supermassive star, first it will form main sequence star. I think in the previous statement you would have read, Sun is a main sequence star. Sun is in this phase right now. And then on undergoing further fusion reaction, average star like Sun, I repeat, average star like Sun, it will become a red giant, and followed by that it will undergo implosion process called as planetary nebula, and finally it will form white dwarf. I repeat, the end product of Sun will be white dwarf. Right now it's in main sequence phase, and then it will progress into red giant followed by planetary nebula. It is going to form only white dwarf. Wherein if you take a massive star, we're going to talk about a massive star. Massive star means stars that may be up to 5 times the mass of Sun. M0 stands for solar mass. By the way, M0, approximate value of M0 or estimated value is 2 into 10 power 30 kilogram. Now, if some star has mass more than 5 times the mass of Sun, then you call it as a massive star. Now, if a star is massive, then it will undergo a process called as supernova explosion. And after supernova explosion happens in the star, that is towards the end cycle, there are two possibilities. First possibility is it can form a neutron star. Second possibility is it can form a black hole. Now, supernova explosion happens when something like this will happen. That is, starting from the outer layer, hydrogen, all the way till iron, Fe2656 will be formed in the star. You see here, outer layer is hydrogen fusing shell. For the people online, I will just zoom this. See here, outer layer is hydrogen fusing shell, where the centermost layer is iron core. When iron is formed, the further fusion cannot happen. And because of this, the star will implode, followed by that, there will be a highly energetic explosion. So this explosion is called a supernova explosion. I repeat, this explosion is called as supernova explosion. So after supernova explosion happens, there are two possibilities. The star can either become a neutron star or it can form a black hole. If it is massive enough, it will form black hole, or otherwise it will form a neutron star. Now, this may be very vague, especially for non-GS students who are attending online. But when you go through the image, you will understand. First, we are talking about average star like sun. Starts from nebula, it becomes protostar, then it becomes main sequence star, then it becomes a red giant, undergoes implosion, it forms white dwarf. So any average star like sun, it will form only white dwarf. It will never form a neutron star. It will never form a black hole. But if you take a massive star, this will undergo supernova explosion and it can form either a neutron star or a black hole. Based on this, read this statement: sun can neither undergo supernova explosion. True, because sun can neither undergo supernova explosion nor form a black hole. Not possible. Only if a star is like 5 times more than sun, it can undergo supernova explosion and it can form a neutron star or a black hole. So this statement is correct. Second statement is correct. No elements heavier than iron can be formed in core of the star before supernova explosion. True. The maximum element that the star can fuse and form, it is iron. And after that, all the heavier elements, that is starting from atomic number 26, all the heavier elements will be formed only by supernova explosion. 2 and 3 are correct. First one is wrong. Answer is B. Answer for this question is B. Astrophysics will be like one least touched topic by the aspirants, but at least there will be 1 to 2 questions regularly. Question about theory of relativity, question about collision of black holes, and then questions about experiments like LIGO. These are repeatedly seen. So make sure you understand about the star system. Can we go to the next one? Which one undergoes supernova explosion? Dhanapriya ma'am. Generally, supernova explosion happens in massive stars. See here, massive stars undergo supernova explosion. Average stars undergo only planetary nebula followed by white dwarf. Online people, do you have any doubts? Can we go to the next one? Okay. Coming to the next question. All right. Most of you have answered B. Few of you have answered A. Okay. So first, let's understand what exactly is gravitational wave. Please understand, gravitational wave is different. The force of gravity is different because gravitational waves are more like a shock wave. That is, if you're going to clap your hands, what happens? It just vibrates the air molecule. So similar to that, when astronomical objects are spiraling on each other, and then if they are going to collide with each other, so this collision will create a shock wave. So these shock waves are called as gravitational waves. So even though I'm using the term shock wave, ideally it should not be called as a shock wave because a shock wave can happen only when there is a medium. I understand, but only for comprehending purpose. Imagine it like a shock wave that is created when two objects are colliding with each other. Now the first one, gravitational waves are created by binary star systems colliding with each other. The one you saw in the animation, true. First one is true. They're asking which is incorrect statement. Second one, gravitational waves travel at the velocity of light. Interestingly, this is true. Most of you have answered B, but understand gravitational waves, these are created when there is a highly cataclysmic event or a high energy event, and it travels with velocity of light. Currently, the only type of gravitational wave that have been detected are compact binary inspirals. This is also true. So which one should be wrong? D is wrong. Answer for this one is D. Before that, I'll explain the third statement. Generally, gravitational waves are divided into two types. First one is continuous gravitational waves, which are created by a single object, let's say a fast spinning neutron star or any single object, if it creates a shock wave or a gravitational wave, you call it as a continuous gravitational wave. The second type is transient gravitational wave, where in GS students, you would have written it as compact binary in spiral, stochastic, ring gravitational wave. All of them, they fall under the roof called as transient. So transient means the event that happens for a short time and that creates a ripple. So all the GS nodes we have written, it's valid, but still they fall under a general category called as transient gravitational wave. Now, the compact binary in spiral, it's a type of transient gravitational wave because compact binary means two. So this is an example for compact binary, two stars orbiting. It's a binary system, and then they get compacted and then they collide with each other. So this is called as compact binary in spiral, which is a type of transient gravitational wave. And till date, we have detected only the transient ones. The LIGO, which is seen in news often, 2016, 18, 21, they repeatedly detected gravitational waves. But these are from collision of neutron stars or collision of black holes, which means generally binary systems are involved. So the third one is also correct. But the fourth one is wrong because gravitational waves are predicted by Mr. Albert Einstein by the general theory of relativity. Wherein what I've given here, modified Newtonian dynamics, this is a theory that gives an alternative explanation for source of the gravitational waves. But till now, the most widely accepted one is the general theory of relativity given by Mr. Albert Einstein. 2018 UPSC question, go through it. They would have asked which of the following are predictions of general theory of relativity. Answer here is D. D is wrong because gravitational waves are predicted by general theory of relativity for the first time by Mr. Albert Einstein. Can you go to the next one? Sir, but black holes' gravity can easily stop light. So see here, Karthik, when something is entering into black hole, it's going to be stopped. But when two black holes collide, they will create a shock or they will create gravitational wave which will travel. So you'll understand about it when we go through the next question. Take a look at this one. All right. First one, black holes have infinite volume and infinite density. You would have fallen for the term infinite, but this is wrong. Black holes have infinite density. That's true. But they don't have infinite volume. That's because volume is expressed in meter cube. See here, SI unit of length is meter, SI unit of area is meter square, and SI unit of volume is meter cube, which means only when something is three-dimensional, you can calculate volume. Wherein if you take black holes, how we predict black holes is everything, that is every matter and radiation, all of them, they get compressed and they are stored in a single point. So black holes are generally said to be a point mass. When you say the term point, it means a single dot. It's a two-dimension one, wherein it's a single dimension where every mass is compressed inside. So black holes have zero volume but infinite density. It may look like a misnomer or very contradictory, but this is the general characteristic. Black holes do not have volume. If you have been imagining black hole like a sphere, understand the field of influence of black hole can be a sphere, but the actual black hole is just a dot. So the first statement is wrong. The probability of finding a supermassive black hole at center of a supermassive galaxy is high, true. The recent discovery is almost all the supermassive galaxies have a supermassive black hole present at the center. Best example is Milky Way. If you take the Milky Way, which is a spiral galaxy, for example, but I'm generally drawing it as an ellipse only for understanding purpose to make it quick. If you take this as Milky Way, the center of the Milky Way, it has a black hole called as Sagittarius A star, often seen in news because Nobel Prize for Physics for the year 2020 it was given for discovery of this one. So most of the supermassive galaxies will have a supermassive black hole, especially at the center. Second one is correct. Third one, black holes are formed when stars reach Chandrasekhar limit. No. If you remember the previous question related to the stars, see here, we discussed about a star system called as white dwarfs. Chandrasekhar limit is related to white dwarf. I repeat, Chandrasekhar limit was predicted by Indian-born astrophysicist Mr. Subramaniam Chandrasekhar. It is only related to white dwarf. Keep in mind, it is nowhere related to a neutron star or a black hole. Now, what is Chandrasekhar limit is? Let's say white dwarf starts gaining mass from the surrounding particles, wherein Mr. Subramaniam Chandrasekhar, he predicted the maximum, give me a minute. Okay. The maximum mass of a stable white dwarf. That is how much a white dwarf can hold the mass, the maximum amount of mass. That is predicted to be 1.4 times the mass of sun. I've already given you the mass of sun. That is 2 into 10 power 30 kilogram. So this 1.4 into m naught, this is called as Chandrasekhar limit. So if there is a white dwarf, and if it's going to take matter from the surrounding areas, including stars, and then if it breaches this limit, this will again explode. That's a different type of explosion. So Chandrasekhar limit is not related to black hole, it's related to white dwarf. Fourth one, two neutron stars can merge to form a black hole. That's possible. I told you when a star explodes, it can form neutron stars. Now imagine two neutron stars colliding with each other. The animation that you see here, this can lead to formation of a black hole, or this can lead to formation of a larger neutron star. Both can happen. So two neutron stars can combine to form larger neutron star, or two neutron star can even combine to form a single black hole. And again, two black holes can merge to form again larger black holes. All these are astronomical events. Now, this is true. First is wrong, second is true, third is wrong, fourth is true, which means two statements are correct. Answer is B. Do you have any doubts in the 12th one? Okay, can we go to the next one? Yeah. Coming to the, and by the way, someone was asking related to the black hole. Who was it? Karthik sir present online. See here, if you take a black hole, this is the point mass which we are discussing about. The centermost part of the black hole, it's called as a singularity, the place where everything gets compressed to a tiny point, wherein if some light or if some particle is traveling near the black hole, there is a maximum limit. So if it is going to enter inside, for example, if it is going to enter this limit, it gets trapped inside. But if it is passing near the limit of the black hole, it will bend, but it will not be trapped inside. So this outermost border is called as event horizon. So I repeat, center part is black hole. The outermost field of influence is called as event horizon. And the distance between the black hole and the event horizon is called as Schwarzschild radius, because he is the scientist who predicted radius of the black hole. So three terms you have to remember. First one, the actual part of the black hole is called as singularity. And then outermost field of influence of the black hole, that's called as event horizon. Imagine it like a border. Imagine a cricket ground, and then at the center of the pitch, you're going to place a piece of grain, for example. So that grain will be black hole, singularity, wherein the grain has influence throughout the stadium. So the outermost border of the stadium, you call it as the event horizon. And the distance between center of the sand and the outer part of the stadium, you call it as Schwarzschild radius. Three important things you have to learn for this prelims. Clear? Okay. Coming to the next question, 13th one. So we have completed space science and astrophysics. Next, we are going to nuclear science. A, B, D, all mixed answers. All right, we'll start with the first statement. India's three-stage nuclear program will use fissile isotopes of uranium and plutonium as fuel. This is true. If you have been wondering why thorium has been eliminated, we'll talk about it, because thorium is not directly used as a fuel. Thorium will be converted into uranium and then it will be used as fuel. So 3 stages. First is stage 1. Next you have stage 2. Next is stage 3. It's a very lengthy topic. I will give you all the 3 key terms. Non-GS students, you can just go through it in internet, or you can go through the website of Department of Atomic Energy. Stage 1, India uses pressurized heavy water reactor, PHWR. Stage 2, India uses fast breeder reactors. And in stage 3, India is planning to use advanced heavy water reactors, AHWRs. Now, the fuel that we are going to use in stage 1 will be, we are already in stage 1, uranium-92, 235. Fissile isotope of uranium is used as fuel. Where in stage 2, we will be using plutonium-94, 239 as fuel. And then in stage 3, again we will be using plutonium-94, 239 as fuel. So while the stage 3 is running, the thorium, which is abundantly present in India, the last year UPSC question, wherein thorium is present throughout the eastern coast and then in Malabar coast, not in the entire Indian coast. It's present only in the entire East Indian coast and then only in Malabar coast. And if you're wondering where it's present in the beach sands, what we call as the monazite sands. And then the highest amount of thorium is present in Andhra Pradesh. By volume or by mass, the highest amount is in Andhra Pradesh. Followed by that, it's present in Tamil Nadu. Followed by that, Odisha. Followed by that, Kerala. Followed by that, West Bengal. Followed by that, Jharkhand and other states. So this is the general concentration. About 30% is present in Andhra Pradesh. Andhra, Tamil Nadu, Odisha, Kerala, West Bengal in decreasing order. Now we will be extracting thorium from the monazite sands. Somewhere around 30% of the monazite sands will be thorium. And after extracting thorium, you will be using in stage 3 as a neutron absorber, not as a fuel, but as neutron absorber. So this thorium 90, 232, this will be bombarded by neutron. We will be creating arrangement for this, wherein this will transmutate into uranium 92, 233. Repeat, it forms uranium 92, 233, not to be confused with 235. Now, this uranium 233 will be again used as fuel in stage 3. After removing plutonium, after a few years, we will be changing the fuel to uranium 233. So, with respect to the first statement, India's 3-stage nuclear program uses fissile isotopes of uranium and plutonium as fuel. It's true. Stage 1 uses U-235. Stage 2 uses plutonium-239. Stage 3 uses plutonium-239, and then followed by that, it also is going to use uranium-233. Generally, different isotopes of uranium and plutonium is used. Second one, India can indigenously build nuclear reactors required for 3-stage nuclear program. True. Initially, we had dependence on Canada. The first reactors were CANDU reactors. But right now, of all the reactor technologies available in India, India can indigenously produce these 2 types of reactor. The pressurized heavy water reactor used in stage 1, and then fast breeder reactor used in stage 2. An advanced heavy water reactor, we have just a test reactor. Based on that, we'll be building larger reactor at a later stage. So all the reactors required for 3-stage nuclear program can be indigenously produced in India. And this is very important for the upcoming prelims. That's because India's largest pressurized heavy water reactor, this is located in Kakrapar in Gujarat. Kakrapar unit number 3. This has 700 megawatt energy capacity. And right now it's functioning. Even our Prime Minister posted a congratulatory tweet for this, because it's a shining example for Make in India campaign. So India is capable of producing these 2. And if you have marked it to be a wrong statement, thinking about dependence on Russia or thinking about dependence on Canada, understand, for pressurized water reactor, PWR, we depend on Russia. The reactors located in Kudankulam, for example, those are pressurized water reactors. But mostly India has PHWR, which can be produced indigenously. FBR, which is present in IGCAR, Indira Gandhi Center for Atomic Research in Kalpakam, which can be produced indigenously. So, which means the second statement, it becomes correct. Third one, the prototype fast breeder reactor will advance nation into second stage of 3-stage nuclear program, not third stage. So answer is 1 and 2 only. A is the answer. you have any doubts in this, can we go to the next one? Online people, would you please repeat those names? Ashwin sir, don't worry. All these names are present here. When you receive the slides, you can go through it. Any other doubts here? All right. Coming to the next question, 14th question. Many of you have answered A, few of you have answered B, and very few of you have answered D. Okay. The main reason people would have chosen A is you would have wanted to eliminate the term violate, because quantum computers will it violate certain properties, where in this case, first one is correct. Quantum computers, they violate Bell inequalities. Nobel Prize for Physics for the year 2022. It's given related to inequalities. Second one, entanglement property. So before you understand this, first let's talk about the Bell inequalities. So the concept of Bell inequalities, it was given by a scientist called Bell in late 1960s, based on a concept called as local realism. So the local realism says that is, if there are two particles that are separated by a distance, these will be independent. In other words, you cannot predetermine state of one particle based on the other particle. Or in other words, particle exist independently. This is called as a Bell inequality. It's a very lengthy concept, but I'm just summarizing it in a very crisp manner or in a very short manner for understanding purpose. So you have two particles. The one particle's state will not be dependent on the other particle. This is Bell inequality. When you talk about quantum computers mainly work based on two principles. First one is called as entanglement. In fact, first you can write superposition followed by entanglement. Sorry, you can write superposition followed by that entanglement. So first, when we talk about superposition, the idea is generally if you take a binary bit, there can be only two states. That is, either it will have 1 or it will have 0, any one at a time. But it's not possible to have 1 and 0 simultaneously. This is possible in a binary computer that uses a transistor, but this is not possible. But when you take a quantum computer, the bits can have simultaneous states. That is, it can be in a form of 1 and 0 simultaneously. This property is called a superposition, the property by which two particles can coexist simultaneously in a single state. That's called as superposition. Now, this superposition is achieved using something called as entanglement. So entanglement means something that is very connected. So how we can achieve entanglement? Two different possibilities. First one, there are many possibilities, but I'll tell you example. Let's say you're generating two electrons using some method. You're generating two electrons. Electron number 1, and then you have electron number 2. Now the electron number 1, it has a spin quantum number of plus half. The electron number 2, it has a spin quantum number of minus half. When they are created, one is having positive half, the other one is having negative half. And after creation, I'm going to separate them. This is going to be separated somewhere, or this is going to be kept somewhere. So I have electron number 2 and electron number 1 that are separated from each other. Now, the state of electron number 2, if it is in spin negative half, I can automatically say the other electron, that is electron number 1, should be in plus half. So I'm predetermining, if I know the state of this electron, I know the state of other electron. This property is called as entanglement. Even if you're going to physically separate materials or particles, state of one can determine the state of other. This is called as entanglement. Where there are many possibilities. Even you can even use light polarization that is given in the Nobel Prize citation here. Let's say one light is polarized by 45 degree, the other one is polarized by 90 degree from a single source. Now, if you know that this light is in 45 degree, the other light should be in 90 degree. So the state of one light is determining the state of other light. So polarization of light, or photons that make the light, or electrons, any such particles or wave can be used for creating entanglement. Now, based on this, first one, it's true because one state is predetermining the state of other one, which is violating the Bell inequality. First one is true. Second one, entanglement of photons or electrons can be used to create quantum computers. True. You have quantum computers created by IBM, Google. Few of them use light, few of them use electrons. Possible. Third one, quantum computers cannot be built without superconductors. This is wrong. Generally, superconductors are used because if you have a superconductor wherein if there's a string of positive charge like this, negative charge will move in pairs inside. Entangled pair of electrons will move inside, which means one will have positive half, the other one will have negative half. Generally, superconductors are used to build quantum computers, but there are many other technologies. You have something like ion trap technology. There are many other technologies where quantum computers can be developed without superconductors also. So which means this one is wrong, 1 and 2 are correct. Answer is B, 1 and 2 only. Fully confused with quantum computers, don't worry, Karthik sir. Mostly, if at all they want to ask, they won't dwell into the technical details because it will look like a pure science paper. Three things that you have to remember whenever you learn about quantum. If you see the last year, they simply asked what's mean by qubit, which is a quantum bit. The one that I described here, this is a binary bit, wherein this is a quantum bit, wherein two can exist simultaneously. So the application of quantum computer is you're going to quadruple or you're just going to multiply the computational power of a computer. That's because bits can exist simultaneously in two different states, which means very complex algorithms and everything can be calculated by quantum computers. Now, when you learn about quantum computers, three things. One is quantum bits, which can use an electron or it can use a light. In this context, please read about quantum key distribution tested by wherein India exchanged quantum keys. So first you have to understand binary bit is different from quantum bits. That's the first thing. Second thing, how the process or the phenomenon by which two different particles can exist in similar state, that property is called a superposition. When you subject light to interference or something, it can have similar state. So the state is called as superposition. Superposition is achieved using entanglement. So entanglement means particles attached to each other or one particle influencing other particle. Entanglement is used to create superposition, which is used for calculation. This is the only thing you have to remember, or otherwise you don't have to confuse much about it. When the advantage is, first, it's very powerful. Second thing, it's very secure, because if you're going to use quantum key distribution, for example, if you're using light, if someone tried to intercept it, you can easily detect it. So advantages, it's very secure, very complex problems can be solved. These are the advantages. When it comes to disadvantages, it's quite expensive. And then if you want to maintain a superconductor, for example, again, it's going to be expensive and energy intensive process. And the technology is very primitive, not accessible for a common man. These are the disadvantages. This is sufficient. Can you go to the next one? Okay, take a look at this. Since you asked about Bell inequalities, first read the Nobel Prize citation, then I'll tell you the next. Okay, based on this, it's violating Bell inequalities because Bell inequality is based on local realism. Local realism says physical states are predetermined and the measurement of properties of one should not depend on distance between them. Wherein here it depends, because if one electron is having positive half spin, the other one is having negative half spin. Clear? Wherein there is one more question here. So what is India's quantum computer development program? It's called as QUIC, that is quantum. Give me a minute. It's located in Raman Research Institute. It's called as QUIC, Quantum Information and Computing Lab. The name of the lab is QUIC. Is it clear? We'll go to the next one. Okay, coming to the next. Okay. Looking at the answers you have given, taken from NCERT, most of you have answered A, B, C, all mixed. Okay, the answer for this one is A. Taken from your carbon compounds NCERT. The last year we had a question from hydrogen compounds related to water, water being a dipolar solvent. Wherein here it is related to carbon. So diamond and graphite both consists of carbon atoms, no doubt. Carbon has a valency of 4. It can form 4 bonds. And why do they exhibit distinctive physical characteristics despite having identical chemical properties? First one. So diamond, it forms a 3D structure, which means every carbon will form single bond. That is, the carbon forms single bond with the surrounding atoms, and it forms a 3-dimensional lattice. Wherein if you take graphite, carbon will have double bond. Like seen here, carbon will have double bond, and very important, it forms hexagonal array. The earlier one is 3D array, and the graphite forms hexagonal array. So only because of this, the overall physical structure changes, while the chemical properties are similar. Wherein how you have to eliminate this particular option is, first one, graphite and diamond are made up of different isotopes of carbon. No, both of them are made up of pure carbon, C612, no doubt. Graphite contains additional impurities, while diamond is made of carbon. No, both carbon and graphite, generally they are considered to be pure forms of carbon. Only the physical characteristics will change. Now this could be a bit confusing. Varying temperature for formation of graphite and diamond. Here, varying temperature is required for formation of graphite and diamond. There is no doubt in that. But that does not account to different physical properties, because graphite will be formed sooner, wherein diamond requires more pressure and more temperature. So no doubt, varying temperature is required for formation of graphite and diamond. But this statement, even though this may be true, this doesn't explain this question, wherein the optimum answer should be A. There are many questions in UPSC where you will get options like this. Two options may look like a very correct statement, but you have to link it with a question. A is the correct answer, D is wrong. Even though individually this statement is correct, for this question, answer is A. Kindly explain the third one. Graphite contains additional impurities while diamond is pure. So for the question, Arun Kumar sir, both diamond and graphite, they are pure. Both are made up of only carbon atoms. It's not about purity. It's only about the physical structure. Ashwin, is it clear? Arun Kumar? Yeah. Okay, coming to the next question. Next, we are going to the ICT, Information and Communication Tech, related to NFTs. All mixed, mostly B and D options were given by people online. Now here first, unlike cryptocurrencies, each NFT, that is a non-fungible token, is unique. This is the keyword. Yes, it is unique and cannot be exchanged for another NFT of equal value. This is also correct. Both may have equal value, but still you cannot exchange. Exchanging means, let's say, person A and person B. If person A has an image and person B has an image, if you're going to transfer like this is an exchange, or more like a swapping. This can never happen. Now, how the transaction will happen is, if A wants to buy an image from, B wants to buy an image from A, first, the money will be settled, generally in form of Bitcoin or any cryptocurrency. And after that, it can be transferred. So transferring is different from exchanging. Transferring means you're not getting equivalent amount of some other object, but here you're getting money and then you're transferring it. So the first statement, unlike cryptocurrencies, each NFT is unique and cannot be exchanged for another NFT of equal value. This is true. If it is of equal value, you can transfer it after getting a cryptocurrency. That is possible, but it's not exchangeable. In other words, if you take a currency, currencies are considered to be fungible, which means if you have 100 rupee, I have 100 rupee. If you are going to swap the money, that's not going to cause a change. Both of them looks alike. So exchanging them does not change the legal tender value. That is called as a fungible one. The currencies are fungible. But when you take NFT, these are not fungible. If I have an image that's cryptographically coded and it is stored in a blockchain. So this cannot be exchanged, but it can be transferred after getting a cryptocurrency. First one is true. The ownership and transfer of NFT are recorded on blockchain network. True, making them transparent and immutable. So most of you would have chosen the second one to be wrong because it says it's transparent. Understand that transactions are transparent, but the users are anonymous, which means every transaction is recorded on a distributed network or distributed block, which is a public ledger basically. So everyone knows that a transaction happened, but no one will know the details about the transaction. So transactions are transparently recorded, and also it's immutable, which means it cannot be edited. It is a permanent record. Once it is done, it cannot be edited. Maybe you can initiate a fresh transaction, but you cannot basically edit it. This is the characteristic of the blockchain itself. It is transparent. That is, the transactions are transparent, and then the records are immutable, and then the users are anonymous. Second one is true. It's possible to create NFT using both tangible and intangible items. True. It includes everything. So if you see this one, this is just a picture of rose. It's a tangible one, but they took a photograph of this, and this was sold for somewhere around $1 million for a Valentine's Day, because NFTs are very costly. And more than this was sold for more than 1 million. It's just a graphic art. So any tangible and intangible, which can include art or a graphic art or a photograph or even music, video, anything that is tangible can be cryptographically coded into NFTs, including a land record. For example, if you physically own an apartment, you can take picture of the apartment and then you can make it as a NFT. It is possible. So both tangible and intangible can be made into NFT. Answer is D, all the above. There are many questions that may rise from this particular one. How tangible one? If I have a physical object, let's say I have a physical object like this, if I'm going to convert it into a image, and then if I'm going to cryptographically encode it, I can call it as an NFT. I exclusively own image of this particular presenter, wherein one more person cannot create a replica. There should be a minimum difference. Let's say it can have additional buttons or a different color, so which means exact replica of NFT cannot be created. Any doubts for this one? Can we go to the next one? Okay. Coming to the 17th question. Simple question taken from NCERT. Okay, very good. Many of you have answered D as answer. First one. All right. Coming to the first statement. Radio wave has the highest energy in the electromagnetic spectrum. No, in the entire electromagnetic spectrum, energy, repeat, the energy, it increases from left to right, which means radio has the least energy, wherein gamma has the highest energy. In other words, energy increases from left to right. Compared to radio, micro has more energy. Compared to micro, infrared has more energy. Compared to infrared, visible has more energy. So you can simply write first one, energy is lower here, when on the right hand side, the energy increases. Next, when we discuss about this, red light carries more energy than blue light, it's wrong. That's because visible, the part of the electromagnetic spectrum that can be seen by you, it's called as visible. Now you have to write it this way. Near infrared, you get red. Near ultraviolet, you get violet, which means the VGR goes like this. Now, violet is closer to ultraviolet, which means it's more energetic. Red is closer to infrared, which means it is less energetic. We generally think red is very energetic, but understand red has a longer wavelength so that it can travel for a very long distance without undergoing scattering. But that doesn't mean they are very energetic. Compared to all these, violet, indigo, blue are more energetic, wherein wavelength will be lesser. So this one is wrong. Or if you will be confused, you can write this one. GS students, you would have been very clear in this topic. But anyway, for other people attending online, you can write in the entire WebGR. If you take violet, energy will be higher, wavelength denoted by lambda will be lower, and then frequency, how frequently the wave will repeat, this will be higher. When if you take red, energy will be lesser, wherein wavelength will be higher, and then frequency will be lower. If you want to visually represent this, you can write something like this. Violet will be like this, wherein red will be like this. The wavelength is longer, but the frequency is lesser, and also the energy is lesser, which means second statement is wrong. First statement is wrong. Second statement is wrong. Coming to the third one, all the electromagnetic waves are ionizing radiation. No, only certain electromagnetic radiations are ionizing in nature. If you take gamma rays, this can lead to genetic damage and cancers, ionizing. X-rays, ionizing. High energy ultraviolet rays, not all ultraviolet rays are not ionizing in nature, but only high energy ultraviolet rays are ionizing in nature, which means the third statement is also wrong. Answer is D. All the statements are wrong. Is it clear? Can we go to the next one? All right, coming to the 18th question. We are coming to the biotech part now. The D option says 3 only. Sorry, it's hidden here. Online people, what are your answers? Most of you have answered B, few of you have answered A. Okay, so first let's understand what exactly is meant by passive immunity. Immunity in human body can be broadly divided into two. One is called as active immunity. The other one is called as passive immunity. So active immunity means in situ production of antibody, or in other words, your body is going to produce antibodies that will oppose the antigen. So if it is produced at the site, or if it's produced inside an organism, you call it as active immunity. Wherein passive immunity means generally ex situ production of antibody, or in other words, we can say ready-made antibodies. Those are called as passive immunity. Now, based on this, active is produced in the body, passive is produced outside the body. First one, antibodies produced by B lymphocyte. This is active immunity because B lymphocyte is a type of white blood cell that produces antibody in your blood, which means it's an active immunity. Second one, mother's milk or colostrum. This is a passive immunity because initial time the babies may not be able to produce a lot of immunity. So the mother's milk, it contains a lot of immunoglobulins, or otherwise called as antibodies, which means mother's milk is an example for passive immunity. Vaccines. Many of you would have chosen vaccines as passive immunity, but understand, vaccine is active immunity, which means vaccines are taken from external source, but they trigger antibody production in your body, which means vaccines, even though they are external sources, they are active immunity. More like vaccine is a tool to induce your B and T lymphocytes. So that's a passive immunity. CAR T cell therapy, recently seen in news, chimeric antigen receptor T cell therapy. That's because the first CAR T cell therapy was conducted in Tata Memorial Hospital in Mumbai. What happens here is, let's say a patient is affected by cancer. Now you're going to extract T cells from them. That is, the T lymphocytes are extracted. and then you're going to insert a gene, more like it's a somatic gene editing. In the white blood cell, you're going to cause a genetic change. You're going to encode certain information so that it can fight the cancer cells. And after inserting the gene, you're going to produce more and more of these cells. And then it's infused into the same person. I repeat, the person from whom the T cell was initially taken, the T cell is modified, more T cell is produced, and then it's infused into the same person. This is called as chimeric antigen receptor T cell therapy. It can target the cancer cells. It will bind to the cancer cells and it will kill them. Wherein GS students, pay attention. I would have told you CAR T cell therapy is a type of passive immunity. But please change your GS notes. CAR T cell therapy is treated as a active immunity, even though it involves a heavy gene editing and everything. While few newspapers have written it as passive immunity. That's why I told it in class. Apologies for the error. Please change it. Anyway, I'll be posting in Telegram channel also. CAR T cell therapy, even though it involves external sources, it is treated as active immunity because the T cell is initially taken from one human and then that is modified and then it's infused into the same human, which means the base for the immunity, that is a T cell, is produced in the body. For that reason, the medical community considers CAR T cell therapy as active immunity. So the answer for this one is 2 only. GS students, make sure or ensure that you change. In biotech topics, we would have written it as passive immunity, write it as active immunity. Answer is 2 only. Can you go to the next question? Coming to the 19th question. Okay, so let me check the answers. Sandeep sir, you've answered skip. Well, many of you have answered, mostly have answered D, few of you have answered C. Okay. First statement, 5G will use radio as well as microwave. This is true. That's because you would have familiarly studied that 5G uses 3 different spectrums. It uses a low band, mid band, and a high band. In other words, it uses sub 6 gigahertz, that is a low band, and then followed by mid band, followed by millimeter wave, or otherwise called as high band. This millimeter wave, it basically falls under the microwave part of electromagnetic spectrum. So even though it's generally called as radio spectrum auctioning for the government convenience, understand 5G, it uses higher bandwidth or millimeter wave, which falls under microwave. 4G does not use millimeter wave. 5G uses millimeter wave, which is a part of electromagnetic spectrum, which is to be labeled as microwave. Now, first statement is correct. Coming to the second statement, 5G internet will have lower latency. Latency, or other words called as ping, which means if you have a device and then you're sending information or you're sending a query to the server, the time taken to fetch the data back, that's called as a ping or a latency. Wherein the second statement is wrong, because any day fiber optic internet will have very lower latency. For example, if you are very closer to the server, the latency can be up to 1 millisecond. Within 1 millisecond, you will send a query and then you will get the result that is fetched from the nearby server. So any day, the only advantage of 5G here is comparatively lesser latency. Compared to the 4G, it has very lesser latency. And very important thing is it is wireless. That's the advantage. Wherein any day, a LAN cable connected to your computer is going to be much faster. Latency is going to be much lesser. Second one is wrong. Third one, the range of millimeter wave used by the 5G is limited to smaller space. This is true. That's because if you imagine this to be a room, for example, let's say I'm sending the low band, mid band, and millimeter wave. So low band will have the least wavelength, which means it can easily penetrate through the walls. Mid band, comparatively lower wavelength and high energy, this can also penetrate through the walls. But if you take the millimeter wave, which is a microwave, it has very short wavelength, which means the throughput, or in other words, data transfer rate. The data transfer rate is going to be much higher, but the penetration is going to be again much lesser. So higher the data speed, lesser the penetration. Wherein lesser the data speed, greater is the penetration. Because the wavelength is longer, it can pass through opaque surfaces like a wall or a building. But if the wavelength is lesser and energy is high, only for a short space you can use it. In other words, if you look at this one, it says frequency increases, penetration decreases. So millimeter wave, the frequency is higher. Like I've given here, the frequency is higher, but penetration is lesser. When if you take a low band, the frequency is lesser, but the penetration is much higher, which means the third statement is right. Coming to the fourth one, this is wrong. So fiberization means how much mobile phone towers are connected by optical fiber. There is the internet cable, the optical fiber you use, how much is connected. Wherein for optimum functioning of a 5G, you need 60%. Wherein right now the major challenge for India is only 30% of the towers are fiberized. If you compare it with other countries, in fact, to be more precise, it's around 33%. If you want to write the exact data, as per the government estimate, somewhere around 33% of the towers are fiberized in India, which means it is not using the coaxial cable or copper cable, but instead it's using optical fiber cable. But if you see other countries, let's take South Korea, for example, it is somewhere around 70% fiberization. And if you take countries like USA, 85 to 90%, which means 90% of their towers are using optical fiber network, wherein this is the major challenge ahead for India. Coming to the next one, which means one is correct, second is wrong, third is correct, fourth is wrong. Two statements are correct. Answer is B. Is it clear? People attending online, do you have any doubts on this? Explain second statement. Second statement, 5G will have lower latency. See, a latency means, let's say I'm sending a query that is www.google.com. Now from my phone, this has to travel to the server. And then from server, it has to fetch a result. Let's say in Google, I'm searching Shankar IAS Academy. When you press the enter button, you have a short lag, correct? So after lag, you're getting the data back. So similar to that, then you send the www.shankarias.in, you're sending it. It's like the uplink. And then it goes to the server and then it fetches the data back. This is called as the downlink. So what is the time required for uplink and downlink together? That is called as latency, or otherwise called as ping. On very simple terms, the time gap between sending and receiving a data, wherein it is lower for 5G, no doubt. Compared to 4G, it's lower, but it's not as low as the optical fiber internet. Is it clear? Sandeep and Dharani Priya ma'am? Yeah. Coming to the next question, 20th question. Many of you have answered C, few of you have answered B. Right now, more answers pouring in for option A. Okay. All right. The first one, India is planning to achieve 20% ethanol blending in petrol. That's true, but not 10% ethanol blending in diesel. We are not planning to blend ethanol in diesel. We are only planning to mix biodiesel in diesel, and that too somewhere around 5%. 5% biodiesel, according to the revised national policy on biofuel. We are going to mix 5% biofuel in the normal biodiesel in the normal diesel, and that to the target year is 2030. For diesel, we are again blending biodiesel. We are not blending ethanol here. petrol does not require anti-knocking properties and all, where inherently it has not anti-knocking properties. So, and also the compression ratio is higher. Because of that, first one is wrong. If the statement was like this, India is planning to achieve 20% ethanol blending in petrol by 2025, then it would have been correct. Here, 10% ethanol blending in diesel, it's wrong. First one is wrong. Second one, petrol with low research octane number is preferred for powerful engines with high compression ratio. This is wrong. Research octane number, or in other words, whenever you go to the fuel pumps, you have normal petrol and then a premium petrol. If you go to Indian Oil, they have something called as X95, which means the research octane number is 95. When you go to BP, they have something called a speed petrol or superpower petrol, something like that. They have more additives, and then it reduces knocking. So higher the research octane number, better it is for the engine. Now, especially for supercars or super bikes, for example, they always prefer or they advise generally to put a fuel with higher octane number. This one is wrong. Third one, ethanol blended petrol has higher research octane number than normal petrol. This is true. Well, there are many concerns related to ethanol blending, wherein when you add more ethanol inside, the research octane number increases, which means the anti-knocking property of the petrol also increases. To understand what exactly is anti-knocking, so if you understand the general working of an engine, so when the piston is moving up in this one, you leave this part now, see only the normal combustion. So first phase is air and fuel mixture goes inside. And after the air and fuel mixture goes inside, the piston moves up. What happens? Both the air and fuel mixture gets compressed. And then the spark plug, generally the spark plug, it gives the spark so that the compressed air and fuel mixture will burn. First step is air and fuel goes inside, valves close, the engine gets compressed, and then the spark plug will ignite the air and fuel mixture. This is a normal combustion. But if you have a high compression ratio, what could happen is the air and fuel comes inside. But before the spark plug ignites, because of the higher compression and because of the high-speed engines, this can undergo automatic combustion because petrols have auto ignition temperatures. So which means if you're going to quickly compress it, before the spark plug gives the spark, the engine can undergo combustion or the fuel can undergo combustion. Now, what is the problem related to this? First one, unnecessary vibration will be there. And then longevity of the engine is reduced because ideally only when the fuel is completely compressed, spark plug functions as the igniter, wherein if it is automatically going to ignite, it can lead to reduction in longevity of the engine. It can lead to engine damages also. So this is applicable especially for high powered engines. Let's say you have a car which exceeds, say, a sedan car that's more than 2000 cc or around 2000 cc, or a SUV that's around 3000 or 4000 cc, then this is required. Now, if you add ethanol or if you have higher research octane number, this phenomenon will be reduced. Basically, your super fuels or your power petrols or X95 petrols, it has higher research octane number and it reduces knocking. Clear? So this and this is wrong. This is correct. Answer is 3 only. Answer is C. 20th question. Answer is C. Do you have any doubts till this? People attending online. Okay, we have completed 20 questions. We have 10 more questions from different fields. Can we go to the next one? All right. 21st question from biology. Okay, answers are between B and D. Okay, first one. Statement number 1. I'm sorry, this option is not visible. It is 1, 2, and 3. Basically, all the above. D option says all the above. First one, trans fats or type of saturated fatty acid. This is wrong. Trans fats are type of unsaturated fatty acids. So to understand this, first let's classify fatty acids, the components of fats. Remember, fats are broken down into fatty acids, or other words, you can say fatty acid forms fat. Now, fatty acids are broadly classified into two types. First one is saturated fatty acid. The other one is unsaturated fatty acid. So here saturation means it talks about the bond formed in carbon. So carbon has a valency of 4, which means in saturated fatty acid, if this is carbon, hydrogen will be here, hydrogen will be here, wherein it forms single bond. Or in other simple words, you can write every carbon in saturated fatty acid will be binded to 2 hydrogen atoms. I repeat, every carbon in saturated fatty acid will be binded to 2 hydrogen atoms. Where an unsaturated means if there is a carbon and if it has a double bond, what will happen? It will be binded only to single hydrogen atom. This is called as unsaturated. In other words, if carbon has double bond, or if some of the carbon is attached to single hydrogen, you call it as unsaturated, wherein this is better for health because this will react with your body. Unsaturated is not good for health. You can write it's a bad fatty acid, wherein unsaturated is good. So depending on how many carbon double bonds are there, you can further subdivide it into two types. One is called as MUFA, monounsaturated fatty acid, that contains 1 carbon double bond. And then you have PUFA, polyunsaturated fatty acid, that contains more than 1 carbon double bond. It can be 2 carbon double bond or 3 carbon double bond, or multiple carbons can have double bond, wherein this is the most preferred fatty acid. Polyunsaturated fatty acid is very good for health. Compared to that, monounsaturated fatty acid is good for health. Compared to that, saturated fatty acids are bad for health. This is not preferred, wherein this is preferred one. Now, coming to the next one we have mentioned here, trans fat. So trans fat is a type of unsaturated fatty acid. I repeat, trans fat is a type of unsaturated fatty acid, wherein generally it's produced in industrial processes. So generally, there are two sources where you can find trans fat. Give me a minute. The PowerPoint just crashed. Please wait a minute. Okay. I think whatever we wrote here, it is volatile. It's disappeared. But anyway, you have written already. Now, when we talk about trans fat, there are two types. One is naturally occurring trans fat, and then you have industrially produced trans fat. When you talk about naturally occurring trans fat, it's often found in red meat such as beef or mutton. Red meats like beef or mutton, they will have small amount of naturally occurring trans fat. Wherein if you take, this may not be beneficial to health, but at the same time, it's not much injurious to health also because it is naturally found. When if you take industrially produced trans fat, first reason is hydrogenation. That is adding hydrogen to the cooking oil. That's called as hydrogenation of oil. The main reason the industries do this is to increase the shelf life. When you make a chips or any other food, and if you're going to hydrogenate it, it's going to have more shelf life. Now, when hydrogen is added to the unsaturated fatty acid, it turns into trans fat, which is very bad for health because it will clog the arteries. Right now, we are trying to eliminate the trans fat. Please go through a program called as Replace by the World Health Organization. India is also having many initiatives to eliminate trans fatty acid. Now, based on this, first statement is wrong because trans fat is not a saturated, it's a type of unsaturated fatty acid. First one is wrong. Second one, adding dihydrogen to cooking oil increases the health benefits. No, just now we discussed hydrogenation of oil is bad for health because it turns normal fats into trans fats. This is wrong. The second half is true. It increases the shelf life. That's true, but there is no health benefit. In fact, it has counterproductive effect on the health. Second one is wrong. Third one, low density lipoprotein and high density lipoprotein are lipids that control blood cholesterol. No, these two are not lipids. Fat is a lipid. Cholesterol is a lipid. Wherein low density lipoproteins, they are a combination of lipids and proteins. They do not fall under lipids. They're a special case of or special type of biomolecule that's a composite mix of both lipid and protein. Now, LDL and HDL are lipids that control blood cholesterol level. If you eliminate this word, LDL and HDL control blood cholesterol level, that's true. But this statement becomes wrong because it's not a type of lipid. It's a lipoprotein or lipoprotein. Answer here, they have asked which is incorrect. Answer is B. All the statements are incorrect. In case if you have missed the term incorrect here, generally UPSC will give the term incorrect and they'll put just a italic font for that. Most of the times we will miss it. So make sure you see if they're telling or they're asking for a correct or incorrect statement. Here, answer is D. Wherein the function of LDL and HDL. First, we'll talk about LDL, low density lipoprotein, familiarly called as the bad cholesterol. That's because generally low density lipoprotein, it dissolves lipids from the liver and then it takes it through the artery. Now, if you ask if LDL is not required, it is required because for cellular mechanisms or if the cell requires fat, then that is transported by LDL from liver to different parts of the body. But if it is elevated, if there is too much of LDL, more than what cell is required, you call it as a blood cholesterol. So when you take a lipid profile test, and if your lipid profile test says there is more amount of LDL than required, it means it's a blood cholesterol. LDL is bad cholesterol, wherein HDL means it performs just the opposite role. This is familiarly called as the good cholesterol. So what happens here is the blood cholesterol will be converted into cholesterol and it will be deposited on the liver so that liver will excrete it. So two things to remember here. LDL, it takes cholesterol from liver to the body, wherein HDL, it deposits fat or cholesterol from the blood to the liver, which means LDL and HDL control the blood cholesterol level, but they are not lipids. Answer is D, 1, 2, 3, and all the three are incorrect. Can you go to the next one? Yeah. Related to diabetes. Three statements are given here. All right. First statement, type 1 diabetes is an autoimmune disorder. This is true. That's because the body cell starts attacking the beta cells in pancreas. And because of that, if a person is having type 1 diabetes, which is familiarly called as the teen diabetes, because it is lifestyle disorder, and along with it, it's also genetic, which means generally type 1 diabetes, the onset is at very early age. Sometimes for children itself, they may have type 1 diabetes, wherein the body will not produce insulin at all. That's because insulin is created by beta cells or produced by beta cells, which are present in pancreas. Now, since insulin is not produced here, it is an autoimmune disorder because a cell is destroyed, insulin is totally not available in the blood. Type 1 diabetes is an autoimmune disorder, wherein type 2 diabetes is a metabolic disorder, which means the pancreas will be creating or the pancreas will be secreting insulin, but the body becomes insensitive to insulin, which means if someone is having high blood sugar level due to lifestyle, let's say because of belly fat or because of sedentary lifestyle, it doesn't mean the pancreas is not secreting insulin. It is secreting insulin, but the body is not absorbing it or the body is not sensitive to insulin, which means the first statement is correct. Type 1 is autoimmune. Type 2 is metabolic disorder. Coming to the second one, type 1 and type 2 diabetes have same management practices. This is wrong. That's because for the people affected by type 1 diabetes, insulin is totally not present in their body system, which means the management practice for type 1 diabetes is taking insulin from an external source. It's called as insulin dependent diabetes. Type 1 diabetes, it's called as insulin dependent diabetes. Where in case of type 2, they will generally prescribe medicines so that the body becomes more sensitive to insulin, which means type 2 is called as insulin resistant diabetes. Type 1 is insulin dependent, which means insulin has to be delivered from external source, wherein type 2 is insulin resistant diabetes. Insulin is present in the body, but the body is not sensitive to it, which means second statement is wrong. Third one, type 1 diabetes is caused by deficiency of antidiuretic hormone. This is wrong. The third statement is wrong. That's because the type of diabetes caused by antidiuretic hormone is called as diabetes insipidus. Diabetes insipidus should not be confused with diabetes mellitus. So what happens here is the antidiuretic hormone, it is secreted by pituitary gland. This helps to maintain fluid balance in the body. I repeat, antidiuretic hormone, it instructs the kidney and also it helps to maintain fluid balance in the body. Let's say antidiuretic hormone is not secreted by pituitary, which means there will be excessive urination leading to weight loss and everything. So the symptoms may be similar to diabetes, but the treatment is totally different, which means type 1 diabetes is not caused by deficiency. It's caused by absence of insulin, not caused by antidiuretic hormone. So that is wrong. While type 2 diabetes is caused by deficiency of insulin, again, that's also wrong, because type 2 is caused by insulin resistance. So the third statement is wrong. Second statement is wrong. First one is correct. They're asking which is correct. Answer is B, 1 only. Generally, people will be confused between insipidus and mellitus. So keep in mind, first one, you can quickly write diabetes. First, we are talking about mellitus, which has two types. First is type 1. The other one is type 2, wherein you have insipidus. There's only one type, wherein the reason here insulin is absent. It's autoimmune disorder. Here insulin is present, but it is resistant. In this case, antidiuretic hormone is deficient or absent. So that's how you classify diabetes. Wherein this is autoimmune disorder, this is lifestyle disease, this is generally genetic disease. Is it clear? Ravi Varman, like I told you, antidiuretic hormone is related to fluid balance, which means the blood composition of different fluids in the blood and also the water composition in the body. It's maintained by ADH. Please go through the endocrine system in your NCERT. It's a very lengthy topic, but anyway, it helps to maintain fluid balance. You can write fluid balance. So pituitary is called as the master gland. That's because there are many things secreted by pituitary. One such hormone is antidiuretic hormone. Keep in mind, it maintains the water balance. One such function of ADH is maintaining water balance. Answer is B. Do you have any doubts till this? Online, is it clear? Ravi Varman, TK, okay. 23rd one. All right. First one. World's first plasmid DNA-based vaccine for coronavirus was developed by India. This is true. The name of the vaccine is called ZyCoV-D. The world's first plasmid DNA-based vaccine was developed by India. It's very important because it's part of mission COVID Suraksha. developed by or developed in association with Department of Biotech. First one is true. DNA-based vaccine for COVID developed by India can be administered in humans, including children and adults 12 years and above. This is true. That's a specialty of the vaccine. For the first time, India developed a plasmid DNA vaccine, because other vaccines for COVID, it uses a different approach, wherein the first plasmid DNA vaccine for coronavirus that's developed by India, and that can be administered for even children who are about 12 years. Third one, world's first intranasal vaccine for coronavirus was developed by India. This is also correct. Recently seen in news, the Incovac, developed by the Bharat Biotech, the same company that manufactures Covaxin. Which means answer is all the statements are correct. Starting from 2018, continuously for 4-5 years, they've asked about vaccine. We are not sure if the same trend is going to be repeated again. But since these are significant achievements made by India in last 2 years, especially related to the COVID management practice, I've taken this question. Clear? And by the way, to understand this is the general approach taken for vaccines. Either you can use an entire microbe for creating immunity, which you call it as a whole microbe approach, or you can use a certain part of the microbe to trigger immunity. That's called a subunit. And then you can use genetic material to trigger immunity. That's called as genetic approach. Under the whole microbe approach, you have 3 types: inactivated, live attenuated, and viral vector. Wherein, so when I put this particular slide in the YouTube channel and then in Telegram, I will put a link to the World Health Organization when it extensively discusses the different mechanisms. For now, first thing you have to understand is inactivated vaccine, where the microbe will be killed and then it will be introduced to trigger immunity. Covaxin, developed by Bharat Biotech, that's an example for inactivated vaccine. Now coming to the live attenuated vaccine, which means it will have live virus, but it's in a very weak form. That's called as live attenuated vaccine. Right now, we don't have live attenuated vaccine that's active for coronavirus. Wherein, coming to the viral vector vaccine, when we talk about viral vector, it works something like this, wherein first you take a virus that does not affect humans. In this case, we take a adenovirus, which is generally from chimpanzee. And then on the adenovirus, you are attaching the spike protein, or in other words, the adenovirus is going to act as a carrier for carrying the spike protein that belongs to coronavirus. Okay, center part adenovirus, outer part spike protein of coronavirus. More like it's a mix of 2 organisms, genetically modified one. This is called as a viral vector vaccine, wherein we have 2 viral vector vaccines in use right now that is produced in India. One is the Covishield. Even though it's produced with the help of Oxford and AstraZeneca, here the brand name is called as Covishield. So Covishield, produced by Serum Institute of India, it's a type of viral vector vaccine. Wherein the Incovac, the nasal vaccine, that's also a type of viral vector vaccine. So wherein in your pre-storming discussions, I would have told you it's a type of live attenuated vaccine, but understand, even though the virus is attenuated, it uses adenovirus. So in the fact sheet, they have particularly given it's a type of viral vector vaccine. So Covishield, manufactured in India, is a viral vector vaccine. Incovac, intranasal vaccine, introduced in the world for the first time, that's manufactured by India, is also a type of viral vector vaccine. And then coming to subunit approach, there is a vaccine called Corbevax, which is developed by a Hyderabad-based company called Biological E. That is India's indigenous subunit vaccine for coronavirus. And then followed by that, for genetic approach, we have the ZyCoV-D. I'm giving only the Indian initiatives here. I'm not mentioning all the vaccines that are approved here, because Sputnik is a type of viral vector. And then the Pfizer vaccine or the Moderna vaccine, they fall under messenger RNA. We are not talking about all the vaccines for coronavirus, but we are talking only the vaccines where India is involved. So Covaxin, Bharat Biotech, inactivated. Covishield, Serum Institute of India, viral vector. Incovac, Bharat Biotech, it's a viral vector. And then Corbevax by a Hyderabad-based company, that's a subunit approach. And then genetic approach, we have ZyCoV-D, which is a plasmid DNA vaccine. Clear? Can we go to the next one? Do you have any doubts till this? All right. Coming to the defense topic. As expected, most of you have answered A, saying one statement is correct related to third statement or the first statement, wherein the answer here is none of the statements are correct. All the three are wrong in different perspectives. We'll talk about it. Coming to the first one. So both Prithvi Air Defense System, otherwise called as sometimes seen in news by the name Pradyumna system. So Prithvi Air Defense System is also called as the Pradyumna system. Similar to that, the Advanced Air Defense System. This is also called as Ashwin system, Ashwin Missile Interceptor System. So when you see the term Ashwin, you should relate it with the AAD. When you see the term Pradyumna, you should relate it with the Prithvi Air Defense System. So when you take a ballistic missile, let's say it is launched from the source, it takes a trajectory like this and then it falls in a particular location. Now, when we try to intercept such ballistic missiles, there are two approaches. First thing is, let's say this is the atmosphere. I mean, the Kármán line that defines the atmosphere, or the border of the atmosphere. First approach is you can send a missile that can intercept it outside the atmosphere and destroy it. That is exo-atmospheric, that is outside the atmosphere. Second approach is after it re-enters in the terminal phase or in the mid phase, you can intercept it and destroy. Wherein, keep in mind, Prithvi Air Defense System is more advanced, which means Prithvi Air Defense System is exo-atmospheric in nature. It can go to altitude of up to 80 kilometers. Even though the said range is 80 kilometers, it is estimated to be somewhere around 120 to 150 kilometers, which means Prithvi Air Defense System can travel outside the atmosphere. It can intercept a ballistic missile and destroy it. Wherein if you take Ashwin system or the Advanced Air Defense System, it is endo-atmospheric. Maximum altitude is up to 30 to 40 kilometers, which means it is inside the atmosphere where the interception will take place. So the first statement is wrong. Second statement, BrahMos is a ramjet-based supersonic cruise missile. Till this portion, it's true. While BrahMos A will be hypersonic cruise missile, no. The upcoming hypersonic cruise missile, which is jointly developed by India and Russia, that's called as BrahMos 2. It's called as BrahMos 2. BrahMos 2 is going to be hypersonic missile, wherein BrahMos A stands for air variant. This can be loaded on Sukhoi flights, wherein this can have a range up to 500 kilometers, and it is again a supersonic missile. Only thing is these are land launched, wherein these can be launched from air. So the second half of the statement is wrong. BrahMos A is a standoff missile. We call it as a standoff missile, and it is again a supersonic missile. Second statement is wrong. Third one is wrong because you would have heard the name called as INS Vikrant very familiarly in news, but INS Vikrant R11. This was the first aircraft carrier of India, not the first indigenous aircraft carrier, because INS Vikrant or R11, it was acquired from UK, wherein the actual name of that INS Vikrant R11 is Hercules. In late 1960s itself, we took it from UK. Right now, it is decommissioned. Followed by that, we had two other aircraft carriers. And followed by that, right now, the INS Vikrant we are using, it has the code IAC-1. That is Indigenous Aircraft Carrier 1. So INS Vikrant in bracket IAC-1. That is India's first indigenous aircraft carrier, wherein INS Vikrant R11 is India's first aircraft carrier, but not indigenous. That was acquired from UK. So far we have got two aircraft carriers from UK and one from Russia. Vikramaditya was from Russia, wherein the present one is INS Vikrant, IAC-1. Repeat, IAC-1 is the indigenous one, wherein R11 is from UK. So which means all the three statements are wrong. Answer is D, none of the above. Is it clear? Can we go to the next one? Okay. Coming to the 25th question. D option says all the above. It's hidden. D option says all the above. Most of you have answered A. Okay. So the answer for this one, interestingly, is D, all the above. We'll discuss one by one. First one, incandescent lamps. That is the normal lamps which we use, the ones with filament, and then CFL and LED lamps. All these can be used for visible light communication. No doubt, you can use a normal lamp, you can use a LED lamp. But when you talk about the data rate, no doubt LED will have higher data rate compared to that CFL, and incandescent lamps will have lesser data rate. But still, the light from any of these can be used to set up a visible light communication, a VLC. First one is true. Second one, visible light communication has higher bandwidth, but at the same time, it has lesser coverage. That's also true. Like I told you earlier, if you take a millimeter wave, it has a limited coverage. Wherein after millimeter wave, there is microwave, you have infrared. And after infrared, you have visible, which means visible light is having very high energy, high frequency, and lower wavelength, which means if you shine a torchlight, it's going to be very bright. But if I shine it towards a wall, it cannot penetrate through the wall. That's because the wall will stop the visible light. In other words, visible light will be easily intercepted by a thick layer of wall or a thick layer of material. So only, or in other words, you can say it's a line of sight communication. In fact, the previous year question related to it, the wrong statement was it can be used for long distance transmission. No, it cannot be used for long distance transmission. It can be used only for line of sight communication, which means the transmitter and receiver, they should be in line of sight. If any object is interfering, let's say if it is a glass, that's a different story. But if it is, if you are having a cardboard or any other wall in the middle, then visible light communication cannot happen. So that's why it is considered to be more secure. That's because it's restricted to a smaller geographical area or a smaller space. But at the same time, the range is very lesser. Radio wave can penetrate through wall, but visible light communication cannot penetrate through walls. So the second one is correct. Third one, most of the reason why most of the people why you have chosen this to be wrong is it says it excite them to ultraviolet light, which is true. If you take a CFL lamp, in all your tube lights or CFL lamps, you have a white color coating, correct? That's a fluorescent coating. What happens is first these electrons excite and they will emit ultraviolet light. So these ultraviolet light, they go and strike the layer, the white color layer. It is going to be bombarded by the excited electrons. So this will cause them to emit light. The light emitted by it is visible light. But initially the light will be ultraviolet. So which means you have a CFL lamp. CFL lamp produces ultraviolet. Ultraviolet strikes on the coating. The coating gets excited because of high energy. And these excited coating, it's going to emit visible light. Wherein the statement that I've given here is, in CFL lamp, mercury atoms are excited to radiate ultraviolet light. True, the mercury present inside, it is excited to emit ultraviolet. Wherein the ultraviolet in turn excites the coating that will emit visible light, which means the light produced inside the CFL lamp is actually ultraviolet. But what we are receiving is visible because of the white color layer on the top. All the three statements are true. Answer is D, all the above. People attending online, is it clear? Okay, coming to the 26th question. Coming to the first statement, lithium-ion batteries have high risk of exploding during the charging process than discharging process. Logically, you can mark the statement as correct because generally the batteries will burst or they will undergo a thermal runaway whenever it is being charged. So we are generally advised not to use the mobile phone while charging or not to speak on a mobile phone while charging. To understand this, first you have to understand how a lithium ion battery works. You have a positively charged diode, which you positively charged cathode, and then you have a negatively charged electrode called as an anode. Now, what is used in lithium ion cells is generally cathode will be, you can write lithium metal oxide. Given the general term, but it could be lithium cobalt oxide, lithium copper oxide, lithium iron oxide. Any metal oxide is used as cathode, where an anode will be, because of higher energy density, it will be a graphite. Graphite is used as anode. Now, let's talk about the charging process. That is, if you're going to, let's say, connect your mobile phone to a charging socket, what happens here is this lithium metal oxide will dissolve. Or in other words, electrons will be knocked out from the lithium metal oxide. Now, these knocked out electrons, they travel from here to here, which means electrons travel from cathode to the anode during charging process. And at the same time, the lithium metal oxide, which forms ions, it will dissolve inside. Ions are dissolved inside. Now, during the discharging process, that is once you remove the charger from the socket, the electrons that are present here, it goes in this direction. That is, electrons travel from anode towards the cathode. So when the cathode starts gaining the electrons, the ions that are present here, they will settle back here. That is, the lithium metal compounds will be formed. It will deposit here. In this case, both oxidation and reduction happens here. Together, it's called as redox reaction. Or simple words you can remember. Oxidation, it's basically losing electrons, which means when you're charging, cathode is getting oxidized because it's losing electrons. Wherein reduction means gaining electrons. So while charging, this is getting oxidized, this is getting reduced. While discharging, this is getting oxidized, this is getting reduced. This can happen. Now, what happens here is when you are overcharging a lithium ion battery, I repeat, when you're overcharging it, more and more ions will be created here. Now, when more and more ions are created here, when you overcharge it, there's a separator here so that it blocks two different ion solution. So this separator will be breached, or it could create small holes in the separator. That's the first cause. Second cause is too much of ions here will release poisonous and fuming gases. If the ion concentration increases beyond a limit, it can release fuming gases. So which can lead to increase in temperature of the battery, leading to explosion. So two things. First, ion concentration increases. Sometimes the separator may be breached. Second thing, when ion concentration increases, poisonous gases may be emitted, which can lead to increase in temperature. This temperature can lead to explosion. So that is why your phone batteries, they have a safety shutter, which means after a certain limit, if your phone heats up, it will say thermal shutdown. That is, when the phone temperature exceeds, or when the battery temperature exceeds a certain limit, immediately your phone will shut down. However you try to turn on, it won't turn on. Only when it drops below a temperature, it will turn on. So during the charging process, you create more ions. There is a greater possibility for producing poisonous fumes and also greater temperature. So the first one is correct. Second one, sodium ion batteries will never replace lithium ion batteries because the energy density, or in other words, if you have this much of lithium ion and if you have the same amount of sodium, same size of sodium ion battery, the energy stored in this is going to be greater compared to the energy stored in this one. The only advantage is it is less dangerous. Mostly it won't explode because of sodium ions. So sodium ion batteries cannot replace lithium ion batteries. Wherein does it have improved energy density? No. Lithium ion batteries have higher energy density. And it has safety features? Yes. Sodium ion batteries have better safety feature, but they have a lesser energy density. Which means if you want a small cell phone and then you put a battery inside, you try to put maximum power inside, 6000 mAh, 5000 mAh, which means Any day lithium-ion batteries will not be replaced by sodium-ion. Maybe we might have a different technology, but not sodium-ion. Second one is wrong. Third one, solid-state batteries is generally preferred compared to lithium-ion batteries for medical devices. This is true. It's because here I said cathode, anode followed by a solution. That is an electrolytic solution here. But if you take a solid-state battery, you don't use a electrolytic solution, but you use a chemical paste here, which means cathode, solid in state, anode, solid in state. Electrolyte, it's not a solution. Again, it's a chemical paste which is solid in state. So comparatively, it is much safer. But the disadvantage here is it is much costlier. And that is why the medical devices that stays inside the body, or sometimes the fitness trackers, for example, they will have solid state battery. Samsung holds a greater amount of patent for solid state batteries right now. So this is correct. If something is going to stay inside the body, or if you want to prefer safety, solid state batteries are preferred. One is correct, second is wrong, third is correct. Answer is 1 and 3 only. A is the answer. 26th question. Answer is A. Do you have any doubts in this? Online people, we'll go to the next one. Yeah. Coming to the 27th question. We have 3 more questions. Since this is a quite lengthy question, I'll give you like 30 seconds extra. You can just go through it again. All right. To understand this, first I'll tell you what is meant by a grid computing. Imagine India has a supercomputer somewhere in NIT Trichy, for example. We have something called as Parampurul in NIT Trichy. So let's say one supercomputer is present in India. There is one more supercomputer present in Australia. One more supercomputer present in USA. Now, all these 3 computers, they're going to work on a task, not on a single task, but more like a single task is going to be executed by all the 3 computers. Let's say I want to perform a weather modeling. India is going to perform or execute algorithm, and then it's going to perform weather modeling. The same algorithm with different data. It's going to be executed in Australia, and it's going to create a data. And then the same algorithm, it is going to be executed by a computer present in USA, but with a different data. And again, it's going to create a data. This is called as grid computing, which means they are independent computers. First key point here is they're independent computers, and they are connected to a virtual computing environment. So which means generally complex calculations, such as very complex mathematical problems or certain weather modeling applications, they are performed through grid computing. 2 keywords to remember here is they are present at different locations. Second, the entity may be totally independent of each other. It's not necessary that a single company should own all these computers. They may be owned by different companies or different organizations. That's called as grid computing. Coming to the next one, distributed computing. So distributed computing means, let's say I have one task to be executed. The task has 10 steps. Now I have 3 computers with me. What I'm going to do is step 1 to 3 will be performed by this computer. Step 4 to 6 will be performed by this computer. Then step 7 to 10 will be performed by the other computer, which means they are executing it individually, or a single task is broken into multiple smaller tasks. and then independent computers are performing it, and then I'm going to assemble it at a single location. This is called as distributed computing. The keyword here is subtasks are assigned to different computers here. You're breaking one task into multiple subtasks, and then the subtasks are given to different computers. Clear? Coming to the next one called cluster computing. So cluster computing, the keyword here is it happens in a small area. Let's say it happens in a single office wherein I have 3 computers. And then let's say this computer has 4 GB RAM. This computer has 4 GB RAM. And this computer has 4 GB RAM. And then I'm running an algorithm, or I'm running a program that requires 6 GB of RAM. So what will happen is this is the primary computer. Since these are connected, these 2 resources will be utilized by the primary computer. This is called as cluster computing. Here it is not on a, that doesn't span over a huge geographical area, but it generally happens in a very small area. That's called as cluster computing, which means multiple computers or servers are interconnected here. All of them sound very similar. Here it is within a company, generally owned by a single entity, wherein here distributed means it can be present in a larger geographical area. One task is divided into multiple subtasks. That is for distributed computing. Grid computing means independent algorithms performed by different computers. Now see this here. Approach allows multiple computers to work together to perform complex tasks, which means you can eliminate the concept of cluster computing here. The resources such as computing power, storage, and network bandwidth are shared across multiple locations and managed by a central entity, which means here it should be related to cluster computing. Sorry, not cluster computing. It should be related to distributed computing, or otherwise grid computing, when it's useful for large scientific computing and data intensive applications. So the most optimum answer here is grid computing. When other things you can eliminate, because cluster computing is not over different areas. This is eliminated. Edge computing is often seen in industry 4.0 or related to the 5G technology. What happens is you have a machine. The machine uses a particular cloud server. And then you try to reduce the distance between the machine and data. So what you do is you bring an intermediate server here. So instead of communicating to this cloud, certain important data are stored here so that it can approach very sooner. This is called as edge computing, reducing the distance between machine and the data. That's called as edge computing, because the data is present at the edge of the machine. So this is not related to these characteristics. And digital twins means you have a computer or you have a system when you are going to create an exact replica of the system, and then you're going to run it in a virtual environment. That's called as twin computing. So in this case, answer should be grid computing. Clear? So in IT parks, which method? Mostly IT parks include cluster computing. If they're not using server, if they're using it within them, or if it is like intra-office, intra-building, then it is cluster computing. Can we go to the next one? The last 2 questions, I made it very simple. 28th question. Give me a minute. Shweta ma'am, online, you're asking for edge computing. See here. Let's say I run a machine. It could be a computer or any industrial establishment. And then it is having all the data stored in the cloud. I assume the size of the cloud is around 1 TB, 1 terabyte, wherein there is a 300 MB data, which is very frequently used by the machine. What I do is I store the 300 MB data somewhere in intermediate server. So very frequent fetches, it need not travel all the way till the cloud, wherein it can fetch it from the nearby server. Wherein for certain data, it can fetch from the cloud. So I'm trying to reduce the distance traveled by the data, especially by the frequently used data. That's called as edge computing. Is it clear? Shweta ma'am attending online. Just like a cache memory, exactly. It's more or less a cache memory, but it's not in a single device. But you have one more device that's going to act like a cache memory. Yeah. Coming to the 28th question. Okay, most of you have answered A, few of you have answered B. Wherein here it is related to United Nations program on HIV or AIDS. So wherein first question, is AIDS curable? Online people, is AIDS curable? Acquired immunodeficiency syndrome, is it curable? Some cases, well, few of you have answered curable, wherein right now it's not curable. Keep in mind, polio or AIDS, all these, they're preventable, but they're not curable. While you might have thought about the stem cell therapy cannot be applied for a larger population right now. It's still in developmental stage. So far we have cleared only 3 people from HIV or AIDS condition, which means right now HIV is not curable. Wherein generally HIV, that is human immunovirus, it belongs to a family of virus called as retrovirus. By the way, AIDS is a much complicated condition which is created by HIV. One thing to remember here is all AIDS patients are affected by HIV, but all HIV patients are not AIDS patients. I repeat, draw something like this. AIDS is a condition. So all the AIDS patients are HIV positive, but all HIV positive patients are not affected by AIDS because AIDS is a much advanced or a progressive condition where multiple parts of immune system will fail. So it is possible to manage HIV infection. Now HIV is caused by a virus called as retrovirus, wherein right now there is no cure for it, wherein you can control it. So controlling is using ART, antiretroviral therapy. ART, or otherwise called as antiretroviral therapy. Now, this ART, it is not a treatment for curing. Understand, it's a life-sustaining therapy, which means as long as the patient is taking antiretroviral therapy, the condition of AIDS will be controlled. They can survive. But if they stop taking the antiviral drugs or antiretroviral therapy drugs, then again the AIDS condition will be spawning again in their body. Now, what exactly is 95, 95, 95? Earlier it was called as 90, 90, 90, wherein first 90 stands for 90% of the people affected by HIV should know their present status. That is 90% of the person living with HIV. We call it as PLHIV, person living with HIV or people living with HIV. So first 90 stands for 90% people affected by the HIV should know their present status. Second 90% means 90% people should have access to the antiretroviral therapy. That is, through the government or through the private hospitals, they should get access to the antiretroviral therapy. But in third 90% means 90% of the people should have the viral load suppressed. The viral load should be suppressed. This was the target that was set for the year 2020. But the world, including India, failed mainly because of the COVID pandemic. Because when the COVID pandemic happened, the first one, people know their status, but they were not given access to the antiretroviral therapy because most of the government hospitals were filled with COVID patients. So the government was not able to give antiretroviral therapy. Second condition was failed, which means automatically the third condition was failed. So the UN program for AIDS, they have a revised target called as 95, 95, 95. That is 95% of the people affected by HIV should know their present status. Second 95 means 95% should have access to the antiretroviral therapy. 95% of the people should have their viral load suppressed. And the timeline is 2025, revised timeline. Revised timeline and revised target. Is it clear? Based on this, the answer should be United Nations program on AIDS. Everything else can be eliminated. Coming to the 29th question. The last one says 2, 4, and 5. D statement. I'll give you additional 30 seconds. You can quickly tell me. The D option says 2, 4, and 5. All right. First one. Global relay of observatories watching transient. Transient means event happening for a very short time. This is present in India. You would have heard about the Hanley Dark Sky Reserve, recently seen in news. India's first night sanctuary. Yes. So in that area, we have something called as Indian Astronomical Observatory. I repeat, IAO. This Indian Astronomical Observatory that is located in Hanley in Ladakh, adjacent to the Hanley Dark Sky Reserve, there are 4 important telescopes that are operated by India. First one is, it's called as Growth India, which means growth is an international program. India is participating in it. That's called as Growth India, which means the ultimate aim of the telescope is it watches any event that happens for a very short time. Let's say collision of asteroid or collision of black holes, collision of neutron stars to create a supernova explosion. All these are studied by Growth Telescope, and it's a coordinated effort because multiple observatories which are part of growth program, they will be observing the same target. First one is present in India. It is in Ladakh. Second one, LIGO, Laser Interferometer Gravitational Wave Observatory, related to observation of gravitational waves, wherein there are 2 LIGOs present in USA, wherein the third one, it's called as LIGO India, which is being built in Maharashtra. It's in Maharashtra. India is getting a LIGO. Right now, the budget is allocated for LIGO because the construction process has started. It is going to be initiated or completed somewhere in 2025 or 26. Wherein, even though we call it as LIGO India, sometimes it's called as INDIGO. That is Indian Initiatives in Gravitational Wave Observation. You can simply remember it as LIGO India or INDIGO. Indian Initiatives in Gravitational Wave Observation. Second one is present in India. Third one, India is a member of Event Horizon Telescope, but we don't have an Event Horizon Telescope. This is like a set of 8 telescopes that are present in different continents. There is one in South America, it's present in North America, Europe, Africa, it's present everywhere, but not in Asia, especially in India. This is seen in news because the first photograph of the black hole that was captured by this particular telescope. It's a network of telescope that operates like a single unit. So India is a member of EST, but we don't have a EST in India. When the question I have specifically given, which of the following scientific establishments are present in India? So keep in mind, India is a member, but we don't have a EST. Third one is eliminated. Fourth one is also eliminated because Chandra X-ray Observatory, it's a space-based telescope that was owned by NASA. That's owned by NASA. Wherein it should not be confused with something called as Himalayan Chandra Telescope. That is part of Indian Astronomical Observatory. Remaining things you can write. Indian Astronomical Observatory, 4 telescopes. One is Growth India. The other one is Himalayan Chandra Telescope. This is different from Chandra X-ray Observatory because this is an infrared telescope. I repeat, this is an infrared telescope, Himalayan Chandra Telescope. And then the other one is Hagar, High Energy Gamma Ray Telescope. And then you have a telescope called MACE, Major Atmospheric Cherenkov Experiment. Or in simple words, you can write, this is related to visible light. This is related to infrared. These two are related to gamma rays. Noted. Okay. So based on this, Chandra X-ray Observatory is eliminated. Event Horizon Telescope is eliminated. This is present. 1, 2, and 5 should be the option. Answer is C. 1, 2, and 5. Coming to the last question. Do you have any doubts on this? People attending online? Okay. The last question I've given here related to liquid natural fuels, not to be confused with liquid natural gas. All right. First one, LPG is primarily composed of propane and butane. This is correct. Wherein the composition may vary depending on the countries. In India, generally it is propane and butane. This is correct. Second one, CNG, compressed natural gases, primarily composed of methane. Approximately around 95% will be methane, wherein other gases will form very minor composition. First one is correct. Second one is correct. CNG is much safer than LPG. Definitely yes, because the density goes like this. LPG has higher density. So what happens when there is a leakage? It will settle very closer to the ground, which means there is a greater hazard for fire accident. LPG in terms of density, I repeat, in terms of density, LPG is denser, followed by air, followed by CNG, which means compressed natural gases, lesser density than air. Now, if CNG is leaking, even though it is kept in a pressurized container, if CNG is leaking somewhere, it's going to float up. Or in other words, it's not going to stay closer to the ground. It will dissipate into the atmosphere, which means definitely CNG is a much safer fuel than LPG. Third one is correct. Fourth one, both LPG and CNG are odorless and colorless gases. This is also true. That's because when you burn methane, you literally cannot see the flame. So, in fact, there is a fire accident that involves the F1 driver. When you search in YouTube, you'll understand. Wherein all of a sudden the methane leaks from the car and then they catch fire. So you could see them trying to put out the fire, but it's very difficult because they cannot see the flame totally. Wherein later on, it took some time to realize that the fire is spread everywhere. Then they moved to a different location and then they put out the fire. So when you burn methane or when you burn LPG or CNG, it does not create a flame. It's a colorless and also it's a odorless gas. This is also correct. Answer is D. All the statements are correct. But also keep in mind, when there is a LPG leakage or when there is a CNG leakage, you will have a smell. That is sulfur. It's called as the mercaptan. We add a small additive so that we know there is a leakage. The characteristic smell, the type of smell that you get from a leakage, it's from a chemical called as mercaptan, which is a sulfur compound. So otherwise, we won't know the leakage. Answer here should be all the statements are correct. Is it clear? Do you have any doubts to this? I think we have a question from Ravi Marman. What is the function of mace? From the previous question, you're asking what is the function of major atmospheric Cherenkov experiment. So see here, Ravi Marman sir, both Hager and Mace, it studies about cosmic ray showers. That is when cosmic radiation enters inside the Earth atmosphere. Cosmic ray showers. Later on, you search this term called as cosmic ray showers. So when cosmic ray enters into the Earth's atmosphere, it just breaks into multiple low energy cosmic rays. And in that process, it will emit gamma radiation. So those gamma radiations are being studied by these two telescopes. They are very sensitive instruments that study about the gamma radiation. Is it clear? Okay. So people are attending online. Please tell me if you have any other doubts from the topics that are listed here. Sir, but a domestic gas has order. Arun Kumar sir, that's what I'm telling. The domestic gas LPG, it gets its order from the mercaptan sulfur. It is not the smell of the LPG itself. Okay. So I hope you were satisfied with the session. And please do mark, you have 4 more sessions. You have the map-based terms on 17th, and then you have Indian economy, followed by IO, followed by environment. So I think Satyakrishnan sir has completed polity. I have completed science and tech. You have 4 other value-adding sessions that will be streamed in the same way through the Zoom ID and through the YouTube. Make sure you attend it, and all the best for your exams also. Yeah. Any other questions? Sir, please explain briefly grid and cluster computing. Okay, see Nitish here. Nitish, sir, imagine this way. Your cousin owns a computer. He's in Delhi. And then you are in Chennai. And then there is one more person who lives in Guwahati. Now, all the 3 computers are going to execute the same algorithm. All these are standalone. All these are execute the same algorithm. Then you call it as grid computing. That's because it's a grid when all these are independent. But at the same time, if you're going to divide a task, let's say you want to process a Word document or you want to run algorithm, you're going to divide it between 3 of you. You're not working independently, but you are connected together. Then that's called as distributed computing. Is it clear? 3 laptops are running in different locations, but all of them are not performing different tasks, but they are performing parts of a single task. That's called as a distributed computing. All right. Okay. Good meeting all of you. And once again, all the best. Thank you.